Hi students, welcome to ACE Online platform. As you all people know, the ACE Online is offering the mock test for the scientific officers BARC 2025. So already mock test 1 is done. In this video, you're going to find the video solutions for that test. And one more thing, so there are 4 more full-length mock tests are available. If you wanted to register for that, you can scan this QR code. So register for this online test series and improve your skills, improve your concepts, and learn the time management and get the exam kind of environment. All the best. Good luck.
Hello, my dear students. I hope your preparation is going on very well. And here I am, B.S. Krishna Verma, faculty in ACE Engineering Academy and ACE Online since 2009. I am discussing about the solutions to this BARC Mock 1 and that too specially network theory. And you know this subject is highly dominating and 99.99 all the questions in this subject are highly numerical. Okay, highly numerical. So at this level, at BARC level, you cannot expect any theory questions, sir. So do lot of problems and practice, you will get it. And do go with all the previous papers of what we published in ACE Academy of BARC original papers, plus our GATE and IES papers also will add on your preparation. Now to the questions what we framed, I am going to discuss this solution and how to do in the easiest and shortest possible time is the challenge here. Yes, I am talking about this subject network theory. Now this is a question which was framed in mock 1. Determine the H parameters for the network below. Now there are two-port networks. Their individual H parameters are given. So for this network H parameter he gave, for this network H parameter he gave. Total combined what are the H parameters he is asking. Now let us understand how these networks are connected. In this port 1 side, if I give total voltage V1, current I1 will enter, come out, again I1 will enter and come out. So current is same means this is series connection na? So port 1 is series connected, no doubt. Okay, current is same, voltage will divide. But what about port 2? In port 2, if I give some voltage V2 which is allowing current I2, see voltage is same. Okay, voltage V2 is same. See this port voltage, this, but current will divide here. Current will divide here. So this current will divide, but voltages are same now. This voltage and this voltage of ports are same. That means here voltage is same, current is dividing means this port 2 is parallel. So here we know, sir, there are two-port networks. Input side or port 1 side series, port 2 side parallel. So we know that son series parallel. So this is series parallel connected. Yes or no? Series parallel connected. Now in series parallel connection, the total H parameters are H parameters of network A plus H parameters of network B. Remember, if both are in series, Z parameters can be added. Both ports are parallel, Y parameters can be added. If both networks are cascaded, A, B, C, D are multiplied. But remember, if port 1 is in series, port 2 is in parallel, then H parameters can be added. But suppose if port 1 is parallel, port 2 is in series, then G parameters can be added. Remember these things. So here, series parallel, H parameters can be added. Chalo, I am adding the H parameters. Now if you add the final answer, let me write here, sir. If you add, this is 1, 2, total it becomes 3. 3 plus 3, 6. And here 2 plus 4, 6. And here 4 plus 1, 5. Okay, so add corresponding, sir. 1 plus 2, 3 plus 3, 2 plus 4 and 4 plus 1. So 3, 6, 6, 5. So answer is A, option A. Okay, na? Now let us go to the next problem. See here, interestingly, determine the current I. So he gave a network with 3 independent sources. Of course, 2 are independent current source. 1 is an independent DC voltage source. And it is a purely resistive network and is asking us to find that current I. Okay. In the circuit shown below, determine the value of current I. Now, I don't want to use mesh, nodal, all these complex things are. Theorems are also unnecessary. Simple KCL, KVL. Now, watch this. I need this current I. But if you observe, this is current I, this is phi. So, if you apply KCL, this current is I plus phi. Yes or no? Yes. This is I, this is phi. So, KCL I plus phi. Out of I plus phi, 10 went. Out of I plus phi, 10 went. So, this become I minus phi. I minus phi. Yes or no? At this junction, out of I plus 5, 10 went, I minus 5. Again, I minus 5 plus 10 is again I plus 5. I plus 5. Again, I and 5. Chalo, with the given data, luckily current sources are more. KCL, I plus 5. Okay, out of which 10 went, I plus 5 minus 10 is I minus 5. Again, added 10, I plus 5. Again, same. Then happily, I will write a KVL. So, I wrote a KCL plus I am writing a KVL. Chalo, now if you write a KVL, see now, 1 into, yes, 1 into I minus 5, okay sir, 1 into I minus 5 plus 1 into I plus 5, okay, 1 into I plus 5 plus 10, and this is, yes, I by 3, okay, plus I by 3 is 0. So I just wrote a KVL, 1 into I minus 5, 1 into I plus 5 plus 10 plus I by 3. Now see, plus 5 minus 5 you remove, this I by 3 plus 2, okay, 2 plus 1 by 3 of I will take I common, is equal to minus 10. So I is minus 30 by, this is 7 amperes. See how simple it is, no need to do mesh and nodal. So after writing KCL and KVL, I got as I as minus 30 by 7. Chalo, minus 30 by 7, option B. Option B, okay. Now let us go to the next problem. For the 2-port network shown below, determine the transmission parameter A. He want only transmission parameter. That is, out of ABCD parameters, only A term he want. Chalo, now if you observe, sir, see, rather than doing in a normal way by writing the definition, okay, and taking, see, you know, in transmission parameters, input voltage, input current are dependent, then output voltage, output current are independent. You remember? Now rather than doing and solving for this network, okay, which is wasting time, okay, because A is V1 by V2 when I2 is 0, like that, rather than doing, see, if you observe carefully, sir, if you observe carefully, can I say this part and this part are cascaded? Yes, they are cascaded, because output of first network is input to the second network. Now we know already ABCD parameters of series impedance branch. The series impedance branch ABCD parameters is what? 1Z01 na? 1. But here Z is Zn 01. And we also know ABCD parameters for shunt admittance model. Now this is impedance. What is the admittance of this? 1 by Zm Siemens. If Zm is ohms, 1 by Zm Siemens is the admittance. So this is 10Y1. Y is 1 by Zm1. And now we know these two networks are cascaded. When these two networks are cascaded, the two ABCD parameters can be multiplied. So the final ABCD parameters are, chalo, if you multiply, see, this become 1 plus Zn by Zm, okay, and this is Zn only, and this is 1 by Zm only, and this is 1. But finally is asking only A term, na? So rather than doing by definition, which takes time, we know this part and this part are cascaded. In a cascaded network, ABCD parameters can be added. Now ABCD parameters of series impedance model is 1Z01. ABCD parameters of shunt admittance model 10Y1. If you product, this is the answer. So in that A term, A parameter only is asking. So what is the answer? 1 plus Zn by Zm. 1 plus Zn by Zm. Okay, simple. Now let us come to this. Now this is a transient problem, but see the question. If the switch in the circuit is closed at t equal to 0, then determine di of 0 by dt at t equal to 0 plus. So he's asking initial condition. So these are initial condition problems, sir. But to get that initial condition, we need to define the circuit at t equal to 0 plus. And you know, inductors, capacitors are quite different. Okay, inductor at 0 plus acts as open circuit with initial condition. Capacitor acts as short circuit with initial voltage. So let us first find the initial condition. First, I will go to t equal to 0 minus. What is the meaning of t equal to 0 minus? Previous steady state. In the previous steady state, switch was open. Now for DC, when the switch was open, we know inductor acts as short circuit for ideal DC in steady state. Now this is 40 volts, this is 4 ohms, this is also 4 ohms, and this is I of 0 minus. So what is I of 0 minus? 40 by 8, 5 amperes. 40 by 8, 5 amperes. So I of 0 minus is 40 by 8, 5 amperes. Chalo, we got I of 0 minus. Yes or no? I of 0 minus is 40 by 8, 5 amperes. Yes or no? Now with this, I will now write the 0 plus circuit. Now if I go to 0 plus circuit, what is the sudden change that happened? Switch has closed. Yes or no? So the same 40 volts is here. 4, this switch has closed, that is the change. But how inductor is behaving? It's 0 plus, inductor acts like open with initial condition. That initial condition is luckily there, na? Yes. So this is however 40 volts, 4 ohms, 4 ohms. And this current, how much we got? 5 amperes. 5 amperes, and inductor acts as open. But I want what? I want di of 0 plus by dt. From Ohm's law, how we will get this? We will get this VL of 0 plus by L. That is the meaning, because V is LDI by dt, na? So I need VL of 0 plus. Chalo, what is VL of 0 plus? This voltage I want, na? VL of 0 plus I want. Okay? Chalo, now if I know this, I will get this. Chalo, now to get this, I will write a KVL here. Chalo, if you write a KVL here, let me write a KVL. So starting from here, this is 5 4s are plus 20 plus VL of 0 plus is 0. So VL of 0 plus is minus 20. Chalo, once VL of 0 plus is minus 20, so answer is minus 20 by L. L value how much he gave? L value 2 he gave, 2. So answer is minus 10 ampere per second. Answer is how much? Minus 10 ampere per second. Okay? Yes, minus 10 ampere per second. That is option A. Okay? There was a typing error, that is why I rewrote, but answer we got. Then come here. The time constants of the circuit shown below is dash. Now he is asking the time constant. Now clearly it is an RC circuit. There is only one capacitor and all are resistors. Of course, ideal sources we can neglect. In terms of reduction, ideal voltage source internal resistance is 0 and ideal current source internal resistance is infinity. But time constant of any RC circuit is tau is R equivalent into C. So I need the equivalent resistance seen by the capacitor. Chalo, let us remove the sources. Ideal current source open, okay. Ideal voltage source short, okay. Chalo, I want the equivalent resistance seen by the capacitor from here. Okay, this is however 1 milliohm, this is 2 ohm, 2 ohm, 4 ohm, and this is 23 ohm, and I want the equivalent resistance seen by the capacitor. Chalo, if you observe the equivalent resistance seen by the capacitor from that port, this is open, current won't flow. Now then 2 plus 2 series, 4 parallel 2, 2 plus 23. So R equivalent is 2 plus 23, 25 ohms. Then tau is R equivalent into C, that is 25 into, what is C value he gave? 0.25 millihenry. 0.25 farad. Okay, capacitor na? 0.25 millifarad. Okay na? Millifarad. Okay, now 25, 25, 625, but here 2 decimal and milli. So 6.25 milliseconds. Yes, the time constants of the RC circuit is 6.25 milliseconds. It is 6.25 milliseconds. Okay, na? That is done. Okay, 6.25 milliseconds. Then for the circuit shown below, determine the value of damping ratio zeta. Okay, yes, damping ratio. Actually, in network theory, we teach damping factor, but he is asking damping ratio. That is a control concept, but from network we can argue. Because we know damping ratio zeta is R by R critical. R critical. But what is R critical? R critical comes when alpha equal to omega naught. That is the condition of criticality. But what is alpha? R critical by 2L is 1 by root LC. From that R critical is 2 root L by C. Chalo, once we know R critical, then R critical by R will be damping ratio. Chalo, let us first find R critical. Now here R critical will be 2 root L by C. L is how much? 1 milli. C is how much? 10 micro. 10 micro, 10 to the power of minus 6. If you observe, here 10 to the power of minus 3, 10 to the power of plus 6 is 10 to the power of 3 by 2, 10 square, 100. Root 100 is 10 2s are 20. Chalo, R critical is 20. Now finally I am asking damping ratio zeta is R by R critical. But what is R? 5. But what is R critical we got? R critical 20. So that is 1 by 4. 0.25. Finally answer is 0.25. 0.25. Option A. Now damping ratio zeta is 0.25. Okay, you know the meaning, right? Chalo, next. Now another question is giving the voltage across the last resistor is 1 volt. Okay, the voltage across the last resistor is 1 volt. All resistors are unity, means 1 ohm. Then the value of Vs. Ulta. See, said all resistors are 1 ohm and the voltage across this last resistor is 1 volt. Now he is asking Vs. Then what I will do, sir, I will apply homogeneity. See now, listen. When 1 volt is across 1 ohm, this is clearly 1 ampere na? Yes, when 1 volt is across 1 ohm, 1 ampere. Now when 1 ampere is going here, 1 ones are 1, 1 ones are 1, total 2 volt. Okay, when 2 volt is across 1 ohm, this is 2 ampere. 2 ampere. Now KCL. This is 2, this is 1, total 3 ampere. 3 ampere. Now again KVL. This is 3 plus 2, total 5 volt. 5 volt. Again Ohm's law. 5 by 1, this is 5 amperes. Now again KCL. This is 5, this is 3, this is total 8 amperes. Now final KVL. 8 ones are 8 plus 5. So Vs is 13 volts. So answer is 13 volts. See what I did, sir, it is a ladder network. First of all, it is a ladder network. Okay. And moreover, it is a bounded ladder, not infinite ladder. So what I did, I applied the principle of homogeneity. See what I did. With the given data of 1 volt, when 1 volt is across 1 ohm, this is 1 ampere. When 1 ampere is going here through 2, this is 2 volts. 2 by 1, 2 ampere. Again KCL. 2 plus 1, 3 ampere. Again 3 plus 2, 5 volt. 5 by 1, 5 ampere. Again 5 plus 3, 8 ampere. 8 plus 5, 13 volt. Okay, so simple Ohm's law, KCL, KVL. Okay, Ohm's law, KCL, KVL. Okay, Ohm's law, KCL, KVL. So that is how we got answer is 13 volts. Simple. Okay. Then the circuit is modeled by the following differential equation. Differential equation given means dynamic response. That means for that circuit, he is finding the transient response, dynamic response. So he gave the differential equation. Then the response current I of t is which form? Now we know in any stable second order circuit, there are three types of responses. Either overdamped, critically damped, underdamped. And those mathematical equations we know now, sir. In overdamped, it is a1 e power s1t plus a2 e power s2t, where s1, s2 are roots. In critically damped, e power minus alpha t, a1 plus a2t. In underdamped, e power minus alpha t, a1 cos omega dt plus a2 sin omega dt. Of course, undamped, undamped and natively damping we don't discuss as far as stable systems are concerned. Chalo, now let us know the roots and the nature of the roots. From that we will declare whether it is overdamped, critically damped, underdamped. Because in overdamped, roots are native, real, unequal. In critically damped, roots are native, real, equal. And in underdamped, roots are complex conjugate with native, real part. So now from this differential equation, let us apply Laplace transform and write in S domain. So this become S square I of S plus 4 I of S plus I of S into 4 is 0. Now if I take I of S common, S square plus 4S plus 4 equal to 0. Of course, this is 4S. Okay, na? So S square I of S, 4S I of S, 4 I of S. If you take I of S common, S square plus 4S plus 4 is 0. So this is the characteristic equation governing the system. Now if you find the roots S1, S2 minus B minus 4 plus and minus root of B square 16 minus 4AC by 2A, 2 into 1. So this becomes minus 4. This is 16 minus 16, 0 na? Minus 4 by 2. So the two roots are negative, real and equal. So here two roots are, because you got how much here? Minus 4 by 2. Minus 4 by 2 means minus 2. So the two roots are negative, real, equal. Negative, real, equal means it is critically damped. Critically damped. Now in a critically damped system, the nature of response, yes, the nature of response is I of t is e power minus alpha t a1 plus a2t. This form you have to search, sir. Chalo, out of given option, e power minus alpha t. Okay, alpha is called damping factor. A1 plus A2t. So this is perfectly matching this now. So C is the option. This will come for overdamped. This will come for underdamped. But critically damped is this. Critically damped. This also underdamped. These two looks underdamped. Okay, because sinusoid and decaying are underdamped. But this is critically damping. So roots are native, real, equal means critically damped. Critically damped means this response. This can happen with option C. Okay, simple mathematical side. Then you see this question. The time period of third harmonic of power supply. The time period of third harmonic of power. See, first of all, our fundamental frequency is how much? 50 Hz. In power engineering, in generation, all over India, our fundamental frequency is 50. What is third harmonic? Third harmonic is 3 times 50. Na? So, third harmonic is 3 times fundamental. Okay, which is how much? 150 Hz. Then automatically, what is the time period of this? Time period of this third harmonic is equal to 1 by third harmonic frequency, 150. 150. So 1 by 150 if you do, yes, you are getting 6.66 milliseconds. Yes, answer is how much? 6.66 milliseconds. It is of course 6.66 milliseconds. Okay, milliseconds. Then everybody, the internal resistance of ideal voltage source. Now we know this as our first fundamental. An ideal voltage source is a voltage source whose internal resistance is 0. Okay. Yes, then only there is no voltage drop, and whatever voltage we generate will also appear across the load. Whatever voltage we generate will also appear across the load, and this is the current. So ideal voltage source is a voltage source whose internal resistance 0. So no losses, no voltage regulation. Whatever we generate will also appear across the load. So answer is how much? 0. Otherwise, the property depends upon the type of load connected. Okay. So in ideal voltage source only that is possible. An ideal voltage source is a voltage source whose internal resistance 0. Okay. So with this, yes, we discussed all the questions of this mock test. And please continue your preparation. Don't give up until you get all the best.
Control systems. So first question, the transfer function of a system given is asking the sensitivity. They simply have to find it what? STK. So STK equal to So you have to find simply STK. So STK equal to dou T by T divided by dou K by K. So that equal to K by T into dou T by dou K. Dou T by dou K. So now we know the T. So write it, find STK. STK equal to, so K by T. What is T? K by S square plus 2S plus K into dou T by dou K with respect to K. So U dash into V, partial derivative, U dash into V minus UV dash by V square. U dash, once partial derivative 1 into S square plus 2S plus K minus U is K into V dash, S square becomes 0, 2S becomes 0, K becomes 1 divided by S square plus 2S plus K whole square. So now you observe here, this square and this will get the cancel, and this KK will get the cancel. Here also K is there, here minus K will be there. This also will get the cancel. Then you find STK equal to, so what you are getting? S square plus 2S divided by S square plus 2S plus K. 2S plus K. So this is the answer. So that means here answer is S square plus 2S. So answer C is correct. S square plus 2S by S square plus 2S plus K. Next, second question. So the forward transfer function of a unity feedback system, type 1 system, they given. So first always given data you write it. So what is given? Type 1 system. Given type 1 system and second order system. It is a second order system. Second order system. Pole at where? -2. One pole at where? S equal to -2. The nature of the gain K is adjusted so that the damping ratio is 0.4. The damping ratio is 0.4. That means we need to adjust the K value such that the zeta should becomes what? 0.4. The above equation subjected to the input, if this particular system subjected to the input 1 plus 4t into u of t, then the steady state error of the system is, so they are asking ESS. What they are asking? Steady state error they are asking. So first, so what is the first order system? What is the second order system with type 1 means? So what is the G of S tell? So G of S will take it as what? K by below. One pole at origin because type 1 system, and one more pole having at 2, that means S plus 2, where H of S equal to 1. Now we need to adjust this K value such that the zeta equal to what? 0.4. That means I need to write the what? Characteristic equation. What is the characteristic equation tell? S square plus 2S plus K equal to 0. Compare with standard form. What is the standard form? S square plus 2 zeta omega ns plus omega n square equal to 0. Compare it. If you compare, what you are getting? K equal to what? What we are getting? K equal to omega n square. Yes or no? K equal to omega n square. That means omega n equal to root K. Omega n equal to root K you are getting. Next, 2 zeta omega n equal to 2. Next one, 2 zeta omega n. 2 zeta omega n equal to 2. So 2 into zeta given 0.4 into omega n is what? Root K divided by equal to 2. 2 will get cancelled. That means root K equal to 1 by 0.4. root k equal to 1 by 0.4. That means what I can write? 10 by 4. So that equal to what? 2.5. That equal to 2.5. K equal to how much tell? So k square you make it 6.25. K equal to 6.25. Then if substitute k in the given system, it will become what? 6.25 divided by s into s plus 2, h of s equal to 1. Now what you have to find? We have to find the what? Steady state error to the what? 1 plus k. 1 plus k means what? It is a step plus ramp combination. So find the steady state error. So if find steady state error. So steady state error for r of t equal to what? 1 plus 4t u of t. So what is the steady state error? ESS for step is what? A by 1 plus kp. For ramp is what? A by kv. So you find kp value. What is kp equation? Limit s tends to 0, g of s. So you substitute here, limit s tends to g of s, you substitute, kp become infinity. What is the equation for kv? Limit s tends to 0, s into g of s. You substitute in g of s, what you will get? 6.25 divided by 2. So now you solve this. So then what I will get here? First one, a is 1, 1 plus infinity, plus here a is 4, 4 divided by 6.25 divided by 2. That means 8 divided by 6.25. That equal to 1.28 you will get. 1.28. That means what is the answer? So answer B. Answer A, 1.28 you will get. So next, third question. So they are given the open loop transfer function of a system given. So if the system oscillates with a frequency of 2 radians per second, it should oscillate with a frequency of 2 radians per second. The value of k is. That means what is asking? So oscillating with 2 radians per second means is given a natural frequency. That means the given system must be a what? Marginal stable. The given system must be marginal stable. So use the RH criteria and condition of marginal stability, then you will get the answer. So now write the characteristic equation. What is the characteristic equation? 1 plus g of s h of s equal to 0. So write it. What is the characteristic equation if you expand? So s cube plus 3s square plus 2s plus ks plus ak equal to 0. Then if you write common, take the s terms common, s cube plus 3s square plus s k plus 2 plus ak equal to what? 0. So then write the what? Routh tabular form. Write the Routh tabular form. So one more time I will write the characteristic equation. So what is that? S cube plus 3s square plus s into what? K plus 2, k plus 2 plus ak equal to 0. Write a Routh tabular form. S cube, s square, s power 1, s power 0. So here 1, alternate here k plus 2 and here s square is 3, here alternate ak. Then if you do product here, 3 into k plus 2 minus ak divided by what? 3. Then here ak. So for marginal stability, what is the condition you have to use? So this s power 1 coefficient make equal to 0 for marginal stability. That means what you are getting tell here? Come on, 3k plus 6 minus ak equal to what? 0. That means what is AK you are getting? 3K plus 6. You consider this is equation number 1. Once the system is marginal stable, we can write the auxiliary equation. What is the auxiliary equation? Tell here. 3s square plus AK equal to 0. S equal to what is omega given? Omega given 2 radians per second. Omega given 2 radians per second. That means S square equal to what? S equal to j omega. So J2 means S square equal to minus 4. That means if write a equation minus 4 into 3 minus 12 plus AK equal to 0. So AK equal to what? 12. You consider this is equation number 2. So 1 equal to 2. 1 equal to 2 make it. So AK equal to 12 na? 12 equal to 3K plus 6. Equal to 3K plus 6. So 6 equal to what? 3K. So K equal to how much? 12. The answer is K equal to 12. So what is the answer here? Answer A is correct. Next question. Here the root locus of a unity feedback system given below. So point at which RLD crosses the what? RLD crosses the imaginary axis at. That means at what frequency it crosses the what? Imaginary axis they are asking. Yes or no? So now you write a transfer function to the given what? Root locus diagram. So what is the transfer function to the given root locus diagram? So G of S equal to some K into. So here observe, is there anywhere 0 here? So one pole at there at what? S plus 4, one pole is there. And as well as here complex pole, actually this is J1 I think. This is J1 plus or minus J1. So that means this is minus 1 plus or minus J1. That means what is the equation tell? S square plus 2S plus 2. S square plus 2S plus 2. And mentioned what? Unity feedback system. H of S equal to what? 1. So now write the characteristic equation. Characteristic equation. So 1 plus G of S equal to what? 0. Then you expand this you substitute G of S and expand this. So what is 1 plus K by S plus 4 into S square plus 2S plus 2 equal to 0. You expand this, the characteristic equation becomes S cube plus 6S square plus 10S plus K plus 8 equal to what? 0. You have to find what? At what frequency crosses the imaginary axis. So then here S cube, S square, S power 1, S power 0. 1, here 10, here 6, here K plus 8. Then here what you are getting? 60 minus K plus 8 divided by 6. Here what? K plus 8. Okay, na? So now for marginal stability, you have to make equal to 0. This you make equal to 0. Row of 0 occurs. Then what happen? What you are getting? K marginal equal to how much you are getting? 52. K marginal equal to 52. Then write the auxiliary equation. What is the auxiliary equation tell? So 6S square, K is called K marginal. 52 plus 8 equal to 0. So 6S square plus 60 equal to what? 0. So S square plus 10 equal to 0. So S equal to what? Plus or minus J root 10. So you find this plus or minus J 3.162. 3.162. That means what is the answer? Answer A. Next, the open loop transfer function of a unity feedback system is given. So, he is asking what is the gain margin and is asking what? Gain margin and phase crossover frequency they are asking. So, here first step, options root will be there. Right. So, here, so gain margin and phase crossover frequency. So, first one, find phase crossover frequency. Phase crossover frequency means the frequency at which phase angle is minus 180 degrees. Solution. First find omega PC. Omega PC means at which G of j omega equal to minus 180. So, minus 180 equal to, what is the angle here? Angle G of S minus 90 minus tan inverse of omega tau 1 minus tan inverse of omega tau 2. Omega tau 2. All minus make it plus. All minus make it plus. So, then what happened? Here it comes 90. 90 equal to tan inverse of omega tau 1 plus tan inverse of omega tau 2. Omega tau 2. So, 90 equal to tan inverse of omega tau 1 plus omega tau 2 divided by 1 minus omega square tau 1 tau 2. Tan 90 is infinity. Tan 90 is infinity. Infinity means denominator term 0. That means 1 minus omega square tau 1 tau 2 equal to 0. So, I simplify this, then you will get omega PC. So, omega equal to omega PC, that equal to what you will get? 1 by root of tau 1 tau 2 radians per second. 1 by root of tau 1 tau 2 radians per second. So, this is called omega PC. Then you have to find gain margin. For gain margin, first I need to find, what is the formula for gain margin? 1 by magnitude of G of j omega at omega equal to omega PC. First find magnitude. So, find magnitude. What is the magnitude? K by omega into root of 1 plus omega square tau 1 square root of 1 plus omega square tau 2 square. Tau 2 square. Now, substitute omega value 1 by root of tau 1 tau 2. If I substitute it, k divided by 1 by root of tau 1 tau 2 again root of 1 plus 1 by tau 1 tau 2 into tau 1 square. Again here root of 1 plus 1 by substitute omega value tau 1 tau 2 into tau 2 square. Tau 2 square. Then you solve this, what you will get till here? If solve this, numerator k into root of tau 1 tau 2 divided by here 1 tau 1 this cancel, here 1 tau 2 will cancel. Again here what you will get till here? Root of what you are getting? Tau 1 plus tau 2 divided by tau 2. Again here root of tau 1 plus tau 2 divided by what? Tau 1. Then again you simplify this, what you are getting? Magnitude equal to k into root, it goes to numerator tau 1 tau 2 divided by tau 1 plus tau 2. This is the what? Magnitude at where? Omega PC. So, gain margin means reverse na? Gain margin equal to 1 by magnitude. That means what is the answer I will get? Tau 1 plus tau 2 divided by k into tau 1 tau 2 is the what? Gain margin. Tau 1 tau 2 is the gain margin. And what is the answer, tell here? K into, what is the answer? K tau 1 plus tau 2. Tau 1 plus tau 2 divided by answer C. So, next. The lead compensator as a pole at what? -4. And what is the solution here? So, you take GC of S, compensator of transfer function, pole at where? -4 means S plus 4. 0 at where? -2 means S plus 2. Simply pi m and omega m you have to find. Convert into time constant form. So, take it 2 common. So, what I will get? 1 plus S by 2 means 1 plus S by 2 means 0.5 S divided by 4, take it common, 1 plus 0.25 S. Compare with standard form. What is the standard form? 1 plus tau S by 1 plus alpha tau S. Compare with that. Then once you compare, tau equal to what? 0.5. Alpha tau equal to what? 0.25. That means alpha equal to what? 0.25 divided by what? 0.5. That means what you will get? 0.5. So, alpha equal to 0.5, tau equal to 0.5. Now, find pi m. Pi m equal to sin inverse of 1 minus alpha by 1 plus alpha. That means sin inverse of 1 minus alpha is 0.5 divided by 1 plus alpha is 1 plus 0.5. You solve this, you will get the answer is plus 19.47 degrees. Plus 19.47 means approximately plus 20 degrees. Then omega m equal to 1 by root of tau 1, tau 2, 1 by root of tau root alpha, sorry. So, here, so omega m equal to 1 by tau root alpha, that equal to 1 by tau. Tau equal to what? 0.5. Root alpha is 0.5. You solve this, you will get root 8 radians per seconds. That means 20 degrees and root 8. Answer is C. Next, the open loop transfer function given, the complex roots form a circle. So, here B greater than A. Then what they are asking? They are asking the what? Center, circle of circle, center and radius. Radius and center, we have to find it. Actually, if you draw a diagram here, so if you draw a root locus diagram, so what they are telling here? One pole at origin and next pole will be A because B greater. So, then next 0, 0 is minus B. Then if you draw a root locus diagram here, if you draw a RLD, here there exists a root locus branch, no doubt. Here also root locus branch exists. You find it, here you will get one break point and here another break point, like the circle shape you are getting. That is given by the data itself. The root RLD is a circle. Circle means what happened? Here one breakaway should be there, or here one break point should be there. Here also one break point should be there. So, then it forms a circle. This is the diagram. So, what is the center and radius? Simply it is a what? Midpoint of break point is a center and distance from the center to any break point is called radius. That means simply you have to find the what here? Break point you have to find. So, find the break point here. Find the break point, solution. So, what is G of S given? G of S, H of S or only G of S? So, G of S, unity feedback. So, K into S plus B divided by S into S plus A given. So, break point to find. Break point, simply what we will do? D by S plus B d by ds of S plus B divided by S square plus AS equal to what? 0. So, make equal to 0. Differentiate it. U dash means 1 into S square plus AS minus U S plus B into V dash 2S plus A equal to 0. Then S square plus AS minus what you are getting here? S square plus AS minus here what? 2S square minus AS minus 2BS minus AB equal to 0. Then what happened? AS cancel. Then what you are getting? Minus S square minus 2BS minus AB equal to 0. Minus AB equal to 0. So, now all this will become plus. Then find the roots. You find the roots. So, it is a second order quadratic equation. Find the roots. So, what are the roots? S1 comma S2 equal to minus B plus R minus root of B square minus 4AC by 2A minus B minus 2B plus R minus root of B square 4B square minus 4A 1C AB divided by 2A. A is 1. So, I simplify what we are getting? Minus B plus R minus 2 also take it common root of B square minus AB you will get. These are the two breakpoints. One breakpoint is what? Plus, and one breakpoint is S1 equal to minus B plus root of B square minus AB is one breakpoint. S2 is minus B plus root of B square minus AB. Sorry, here one is minus, one is plus na. So, here I can take first one plus, second one minus. So, here minus, this is the breakpoint. Then center is what? Midpoint of the breakpoint. Center equal to midpoint you take minus B plus root of B square minus AB minus B minus root of B square minus AB divided by 2. Then what happened? BB. Then what happened here? Minus kada. So, here, so minus B, here, 1 minute. Right. So, what happened here? This is plus and minus, both will get cancelled. Then what you are getting? Minus 2B, yes or no, divided by 2. That means the center is nothing but minus B comma 0. The center is nothing but minus B comma 0. Radius is nothing but distance from center to any breakpoint. What is the center? I got it minus B comma 0. One breakpoint you take, any one breakpoint you take. If I take the first breakpoint 1, so what is the breakpoint 1? If I take it minus B plus root of B square minus AB. So, now tell what is the distance minus B to this? The distance is nothing but R is nothing but what is the distance? Minus B both will be what? Same points now. So, that means this will give the distance. That means B square minus AB becomes the what? Radius. Okay, na? So, next question. The time response of the standard second order system unit step input first peak is 5 times of the first overshoot. So, what is the information given here? First peak equal to 5 times of first overshoot. 5 times of first overshoot given. So, first peak is represented by C of TP. C of TP is the peak value. So, first peak is what? C of TP equal to 5 times of MP. Overshoot is called 5 times of MP. So, what is first peak value? 1 plus MP. equal to 5 times of MP. That means what you are getting, tell? MP equal to how much you are getting? Find MP value here. So 1 equal to 4 MP. So then MP equal to 1 by 4. That means what you are getting? 0.25. So what you have to find here? The damping ratio you have to find it. So what is the formula for damping ratio? Simply zeta equal to root of ln of the value, MP value. What is the value? 0.25. ln of 0.25 whole square divided by pi square plus ln of 0.25 whole square. Solve this, you will get the answer is 0.4 you will get. The answer is 0.4. So which is the answer? So answer C is correct. Next, an LTI system, here R1 is given, R1. So input R1 of t given as alpha u of t is given, and R1 of s equal to what? Alpha by s. Next, and produce the C1 of t. So what is C1 of t given? 1 minus e power minus 2t into u of t given. So you write C1 of s. Next, R2 and another system, R2 is beta 2. R2 of t given is beta into del of t. If apply Laplace transform, R2 of s is simply beta. It's not del of t. Laplace of del is 1. Then what is asking? When these systems are cascaded, overall transfer function is given this 1 by s plus 1, s plus 2 given. Then you have to find the value of what? Alpha and beta. So now first take the first system. Take the first system. If you take first system, so this is what here? G1 of s. Here R1 of s. Here C1 of s. So here you find G1 of s, because you have to find G1, G2. You given G1, G2, make equal, you will get the answer. So when two blocks are cascaded, we need to do the product. So what is G1 of s tell? C1 of s divided by R1 of s. What is C1 of s tell here? So 1 minus e power minus 2t. Apply Laplace. So 1 u of t Laplace 1 by s minus 1 by e power minus 2t na s plus 2 divided by R1 of s alpha, I think alpha na? Alpha by s. Alpha by s. Yes or no? Alpha by s. So then you find G1 of s. You find G1 of s. What you are getting here? If you do s plus 2 minus s cancel, and what I will get? Numerator 2 I will get 2 by s into s plus 2 divided by alpha by s. Then ss will get cancelled. Then what you are getting? 2 by alpha into s plus 2. 2 by alpha into s plus 2. Similarly, take the second system. R2 of s. Here take G2 of s. Then output is what? C2 of s. Find G2 of s. Find G2 of s. That is nothing but what? C2 of s by R2 of s. So what is C2 of s given? C2 of s is given what? C2 of s here 4 into e power minus t. 4 into e power minus t means 4 by s plus 1 divided by beta. So that means 4 by beta into s plus 1. So overall transfer function, if both the blocks are cascaded, it is a product only. G1 of s into G2 of s. Then what you are getting? 2 by alpha into s plus 2 and 4 by beta into s plus 1. So then what is the answer you are getting? 8 by alpha beta into s plus 1 S plus 2. But what is G1, G2 given? G1, G2 is given is, what is G1, G2? 1 by S plus 1, S plus 2. So that means it is equal to 1 by S plus 1 into S plus 2. Then what happen? You get cancel, get the value of alpha, beta. So this all will cancel. That means what you are getting? 8 by alpha beta equal to what? 1. Then alpha beta equal to 8. So the answer is 8. Answer is D.
So let us check out the questions what we have given in the exam for electronic devices and circuits. Go with the very first question. Have a look carefully, dear students. For an NMOS transistor, VDS versus VGS. If you check it out, VDS is nothing but output voltage. VGS is nothing but input voltage. That means here examiner has given the transfer characteristics. Okay, transfer characteristics. According to the given conditions, and he's expecting the regions A, B and C respectively, maybe cutoff region or triode region or saturation region. That means the quiescent point. If the quiescent point is chosen at a particular position, what could be the region here? Okay, the operating region, operating points are very important to justify the status of a transistor. I hope you might be knowing about that. Now let me know. It is very easy question. Students, have a look carefully. If you check it out here, my dear boys and girls, if you check it out here, students, let me take region A. In this region, let me take region A. So whatever may be the voltage you choose, the VGS is less than VTH. Am I right here? So in this region, it is very clear to say that VGS is less than VTH. Whenever VGS is less than VTH, indicates the MOSFET never be entered into on stage. Why? Because minimum I need a channel. To produce a channel, VGS must be at least greater than, VTH, threshold voltage. But it is less than VTH represents no channel, indicates no current. Hence, it represents cutoff. So option A, operating region in A represents cutoff. So A, B and C. So cutoff. That means option A might be right answer, option B might be right answer. Option C, it is absolutely wrong, and option D is absolutely wrong. Hope you got the point, dear students. Option C and option D are wrong. So only two choices we have, option A and option B. Now let us have a look carefully. What about option B? Operating region B, Let me know, dear students, let me know here. In this region, that means you please choose any region. So this is the point examiner has given, which is nothing but VGS minus VTH. For example, let us assume that I have chosen this point. So below that voltage, choose any voltage at VDS. That means what? At this region. Assume this is the region of VDS. So choose any voltage of VDS. So this point is nothing but below VGS minus VTH. I hope you got the point here. Choose any voltage of VDS. I repeat, choose any voltage of VDS. This is the point which is at least equals to VGS minus VTH or less than VGS minus VTH. That clearly representing, any voltage or any point if you choose below this line or below the boundary line of VGS minus VTH, that operating region must be treated as what here? Triode. Hope you know that VDS less than VGS minus VTH and VGS greater than VTH. That clearly represents triode region. Clearly represents what, dear students? Triode region. So operating region B represents it is a triode region. So first is cutoff, second must be triode. Yes, I think option A might be right answer. Saturation is highly impossible. And whereas if I choose any point, choose this point, whatever may be the point you choose, VGS is greater than VTH, first point, and this point with respect to VDS is greater than VGS minus VTH. That clearly represents VDS greater than VGS minus VTH and VGS greater than VTH. That clearly shows it must be in saturation. So cutoff, triode and saturation must be the right answers for this first question. So this is for your notes purpose I have given, dear students. So interested people can pause this video and you can check out what I have explained you onto the screen for your notes purpose. Okay. Come with the second question, dear students. A PN junction diode has Na acceptor doping density and ND 10 power 16 ND donor doping density. So Na he has given, Nd he has given, p-n junction diode. So this is for p-type semiconductor and that is for n-type semiconductor. P side Na he has given, n side Nd he has given. Okay, fine. What is the excess hole concentration? Very important, excess concentration. So for example, if I say forward bias, majority carriers cross junction and it obey law of junction, correct or not, dear students? So that gives you the excess concentration of carriers. So what is the excess concentration of carriers at edge of the depletion region? That is what I discussed about law of junction, right? Region on n side, if a forward bias voltage of 0.6 volt is applied, that means I need relation between excess concentration in n side with respect to voltage. I hope you remembered. So in n side, excess concentration, they are minority. So delta P, which is nothing but what here? Pn naught into, have you remembered or not, dear students? Exponential diode voltage by Vt minus 1. That's it. Where you know Pn naught is none other than what here? Ni square by Nd approximately equals to Nd I can take, right? So you know this is mass action law. I hope you remembered. So Vd examiner has given how much, guys? 0.6 volt, and Vt I know 0.026 volt, 26 millivolt at 300 degree Kelvin, and Nd examiner has given how much, guys? 10 power 16 per centimeter cube, and Ni square. Ni examiner has given 10 power 10, so 10 power 10 whole square per centimeter power 6. If I can substitute, I'll be getting the final answer over here. By solving, you'll be getting 10 power 14 per centimeter cube. So option B will be apt for the given question. Come back to third interesting question, dear students. So a P plus N junction diode has Na and Nd. You know, P-N junction diode, P-type semiconductor doping examiner has given, N-type semiconductor doping examiner has given. Then what is the built-in voltage? Very easy question, guys. If no condition is given, we are supposed to go for step graded diodes, right? Not linear graded, step graded diode. And you know, KT by Q. Remember, dear students, log mod Nd Na by Ni square. Of course, it is natural logarithm base E. I think Nd examiner has given how much? 10 power 17 per centimeter cube. Check out the units clearly. Na the same, centimeter cube. So 10 power 20 per centimeter cube. No need to change the units, I understand. And room temperature 300 Kelvin. So KT will be 0.026 volt. Am I right here? Thermal voltage is 26 millivolt, examiner has given, and Ni he has given. So here Ni square 1.5 into 10 power 10 whole square per centimeter power 6. That's it. So if I can solve, I'm going to get the answer. So the answer you'll be getting almost equals to 1.005 something in that range you will be getting. So answer is almost 1 volt. See, option A must be right answer for the given question. One more very interesting question, the easiest question. Have a look carefully. So above figure represents the characteristics of a solar cell. You know, this is open circuited voltage and that is short circuited current. Have you remembered, dear, solar cell? Solar cell indicates it is almost like a photodiode behavior, but the quiescent point you are supposed to choose in the fourth quadrant. The Q point we are supposed to choose in the fourth quadrant. That's why it is an active device, photovoltaic cell, right here. So which of the following is the correct expression for open circuited voltage? Okay, fine. Open circuited voltage equation, it is open circuit and it is a direct formula. VOC is equals to, you know, you will be getting like a KT by Q log 1 plus photo current by leakage current. I am repeating, VOC is equals to KT by Q log 1 plus photo current by leakage current. So VOC is equals to VT log 1 plus, no, this is wrong. VOC is equals to I naught by L, wrong. VOC is equals to KT by Q log 1 plus photo current. IL is a photo current, right? Then IL by I naught, this is apt for the given question. VOC is equals to I naught by L is wrong. Photo current by leakage current is right. So this is direct question and direct formula. So go with this one more very interesting question, dear students. But if you want to do this question, you must be having some idea about a CMOS inverter. Yeah, please take care of that. It is very important for PSUs. I mean to say the engineering services, PSUs like a Baba Atomic Research Center, Indian Space Research Organization like that. Okay. So consider a CMOS inverter fabricated in a 0.2 micrometer, process for which VDD is 2 volt, threshold voltage. It may be for NMOS or PMOS. Examiner has given 0.7 volt. And mu n cox dash, okay, mu n cox dash process transconductance parameter 200 microamperes per volt square, and W by L of n side is 2. The peak current of inverter, peak current. Have you remembered, dear students, peak current exists only when the voltage will be VDD by 2. Peak current, that means, there exists peak current only when input voltage is equals to VDD by 2. There exists peak current. And no doubt Q point for Qn and Qp will be in saturation. Excuse me. Have you remembered, dear students? If you are not remembered, just for your notes purpose, I have given you this. Have a look carefully. So this is the transfer characteristics of an inverter. I hope you know that, right, dear students? This is the output and this is input. So whenever the voltage, input voltage, is below VTH, it is very clear that the transistors will be under cutoff. So whereas in this region, that means what? This is input low and between threshold voltage. Qn will be in saturation, then Qp will be in triode. Whereas in this region, both the transistors will be under saturation. That means what? The exact value I can say input voltage is VDD by 2. Whereas in this region, Qn and Qp, Qp is in saturation and Qn is in triode in this region. I hope you remembered. And here Qp is off. So if both the transistors are on, only at VDD by 2, exactly speaking, both will be under saturation. Otherwise, one will be in triode, other must be in saturation. Qn is in triode, Qp is in saturation. Qp is in triode, Qn will be in saturation. That means at the end of the day, when transistors are on, I repeat, both the transistors are on, out of both, any one of the transistor must be falling under saturation. Whereas at exactly VDD by 2, both the transistors will be falling under saturation. Correct or not, dear students? So for VA between VTH and VDD by 2, the region and the status I have given. For VDD by 2, exactly both are in saturation, and between VDD by 2, VDD minus VT, Qn is in triode and Qp is in saturation. So for each of these three cases, a conducting channel is present. That's what I said. Whenever MOSFET is on, conducting channel exists. Whenever conducting channel exists, this is the way how I'm going to get the current. So for example, if I represent this is A, this is B, this is C, and that is D, A to B, the current is getting increased, and B and C, the place where saturation exists, right? VDD by 2, saturation exists. So saturation represents highest current. Then again, it is falling and reaching towards the cutoff to the D value. Am I right here? So this is the place where exactly I'm going to get the peak current, or we say maximum current. So peak current exists when Vi is nothing but VDD by 2. Just I'm recollecting because this is not the class to teach all the CMOS inverters. Just I'm recollecting because you are going for the numericals. You're supposed to recollect it very fast, okay? So now speak out, guys. So Q point is under saturation. Therefore, what will be the drain current? ID is equals to half mu n cox dash double by L into VGS minus VTH whole square. That's it. Whereas VGS is nothing but what here? VDD by 2. Everything is done. Just substitute there, you will be getting the drain current here. So dear students, by solving half mu n cox dash double by L into VDD by 2 minus VTH whole square, from the given data, if you can solve, you'll be getting the answer as 18 microamps. So option B is apt for the given question. But understand clearly, power dissipation and everything, all these are very important parameters in IC fabrications under the CMOS technology. So if this drain current is large, no doubt power dissipation will be high, I square R. If you want to reduce the power dissipation, the drain current, dynamic power dissipation, the drain current need to be getting decreased, or at least you're supposed to increase the threshold voltage. So for a notes purpose, you can have a look carefully, dear students. But my humble appeal is, before entering into the numericals, please go through the concept in a clear way. That will give you a lot of conviction. Let's enter into one more very interesting question. Students, which of the following is a result of base width modulation of a transistor? I hope you know base width modulation. Whenever collector voltage increases or collector junction voltage increases, depletion width will be increasing between base and the collector. As we know, base width is very small. So at a particular voltage, the depletion width completely occupies the base. Due to that, effective base width, WB dash, effective base width will become 0. Recombination will become 0. IB will become 0. Then IC is equals to IE. So IB decreases, IE increases. That is the beauty of a base width modulation here and early voltage. Exactly the voltage at which this happens, where IB is equals to 0, WB dash is equals to 0 is called a early voltage. And this effect technically we call it as early effect. Remember or not, dear students? Now check out. So base width modulation, effective base width must decrease. That means what? Effective base width, WB dash must be decreasing. So IB must be decreasing. Am I right, dear students? So recombination decreasing. And have you remembered, dear students, what is beta star? Beta star, probability of emitter majority carriers reach collector. Remembered? So IC by IE majority. What is gamma star? Emitter injection efficiency, probability of emitter majority carriers reach base. So it is IE majority by IE. So you know alpha F or alpha DC, forward active. What is that, dear students? So which is nothing but IC by IE. I can write like this. So IC by IE majority plus into IE majority. This is IC by IE. Therefore alpha F is simply is equals to what here? Beta star into gamma star. Excuse me, true or not, everybody in the class? So all the things we have discussed clearly. Now let me know, dear students, here IC, beta star is nothing but what here? Base transport factor, probability of emitter majority carriers reach collector, true or not? So this will be increasing. So this is getting increased. This is increased. So whenever that is increased, no doubt this alpha going to get increased. Now check out the options what examiner has given. Effective base width increases, absolutely wrong. Effective base width decreases. Chances of recombination increases in the base, absolutely wrong. Why? Because the recombination in the base is getting decreased. Base transport factor increases, perfect. Because beta star is getting increased. Base transport factor decreases, absolutely wrong. So option C is apt for the given question. Just try to recollect what we have discussed in the class. Now have a look carefully. The open emitter breakdown voltage. Have you remembered, dear students? Breakdown voltage. It may be a common emitter or common base. It must be avalanche breakdown, right? So open emitter breakdown voltage for common base, this is BVCBO. It is like a 200 volt. And the current gain beta F, or we can say beta DC, examiner has given as 120. And empirical constant, commonly it will be in the range of 2 to 6. Examiner has given 3. And calculate the breakdown voltage of a transistor connected to open base configuration. That means what? BVCEO. Open base indicates BVCEO. Have you remembered, dear students? BVCEO is equals to BVCBO into 1 by beta F whole power 1 by n. If I am not wrong, this must be the right formula. Correct or not? So I think every data is given by the examiner. So if you could substitute that, you will be getting 40.5 volt. Must be the right answer. So apt option for this given question is option D. So go with one more very interesting question. The parameters of an n-channel MOSFET are mu and cox dash, that is 0.6 milliamps per volt square, threshold voltage 0.8 volt, drain current is 1 milliamps, applied voltages VGS, and the source to body, I meant to say source and body both are shorted, so no body effect here. We are very happy. Gamma you can avoid, and VDS is 4 volt. The value of W by L. Okay, fine. N-channel MOSFET, clearly representing it is NMOS. Drain current is given. Okay, VGS is given. Sir, what is VGS? First you tell me. VGS is 1.4 volt. What is VDS? 4 volt. And threshold voltage is how much, guys? 0.8 volt. Now, you please tell me. It is very clear. VGS is greater than VTH, clearly showing MOSFET is on. Next. What is the relation between VDS and VGS minus VTH? VGS is 1.4 minus VTH. I think VDS is 4. It is clearly representing greater than 0. So this clearly shows it is in Q point is in saturation. Q point in what here? Saturation. So MOSFET is biased in saturation. Very happy. So I think I can easily get the answer right now. Whenever it is in saturation, what is ID? ID is equals to half mu n cox dash W by L into VGS minus VT whole square. That's it. Correct or not, dear students? I think examiner has given this ID value, which is 1 milliamps. Mu n cox dash examiner has given how much, guys? It is 0.6 milliamps per volt square. Okay, so amps per volt square. And W by L we need to find. And what is VGS? VGS just now we have written 1.4 volt. And what is VT? VT is a 0.8 volt. Completed. So I mean to say, if I can solve, I'm easily going to get the value of W by L. So if you can solve, you're going to get 9.26. W by L value will be 9.26. No units right here. So option A must be apt for the given question. Very easy question, straightforward, direct question. So in a MOSFET, the drain to source voltage is very small. For example, let me say common source. Students, if it is VDS and if it is ID, okay, assume that VGS is constant. At a particular constant value, I understand this must be the characteristics right here at a specific VGS. Okay, it is very clear. This is pentode region where I can use it as an amplifier. Am I right here? And this is a triode region where I can use it as a voltage variable resistor. Right? Now speak out. So in a MOSFET, if the drain to source voltage is very small, drain to source voltage is very small, then the device can be amplifier. No, because it needs some large value. Device operates in saturation. No, pentode region is also called as saturation region. No, the device operates as a voltage dependent resistor. Yes, voltage variable resistor or voltage control resistor or voltage dependent resistor. Perfect. This is absolutely apt. The device operates as a constant current source. No, because constant current source, saturation, amplifier, all the three belongs to the same statement of pentode region. In pentode region, MOSFET can be used as a constant current source. MOSFET is an amplifier. MOSFET is an active device. Excuse me, right here. And like constant current source, whatnot. If you want to operate that, it must be in saturation region, not in the triode region. So option C is apt for the given question. Very easy questions, I believe, right here. We discussed a lot of concepts in the class. So come back to one more interesting question. Last but not least question, I understand. The output resistance of a PNP transistor R0, which is, R0 180K, okay, and early voltage 80 volt. The change in the collector current, so DIC is how much? Oh, DIC is how much? Where DVCE is changing from 2 volt to 5 volt, indicates it clearly showing that 3 volt. Am I right here? It is clearly showing that 3 volt. I hope you know. For example, if I draw the characteristics, it is VEC, not VCE, okay? VEC, because PNP transistor. And if I say this is IC, this must be the characteristics. Whenever I am discussing about early effect or early voltage, it must be in the forward active region. So here there is a slope, excuse me, at a particular voltage of input, at a particular input current, sorry, at a particular, IB, there is a slope here, there is a slope. Excuse me, right here, students. So that is what he is asking. So what is R0? First of all, tell me. R0 is nothing but DVCE or, like DVEC, I'm sorry, this will be DVEC. So 2 to 5 volt nadir, DVEC, okay. So because it is PNP, it is not NPN. So DVEC by DVEC whole divided by DIC, that's it. DVEC by DIC, because that is the 1 by slope. Slope is nothing but dy by dx. 1 by slope is nothing but resistance, right here. So it is very easy. So what is R0? It is 180K. Therefore, what is DIC? So what is DVEC? 3 volt. 3 by 180 milliampere. So if you can solve, you are going to get the answer. So by solving, you are going to get 0.016 milliampere. I believe that must be 16.7 microampere. So the answer for the given question must be 16.7 microampere, 16.7 milli, no, 16.7 microamp. This is wrong, this is wrong. So option B is apt for the given question. I believe you understood the way how to solve this type of numericals, dear students. Just prepare well for your exams and best wishes.
Let us see signals and system questions related to. What is the first question statement? Impulse response of an LTI system is shown below. H of t is given. The step response of the system is. What is step response relation? S of t equals to integral minus infinity to t h tau d tau. So it is given as 2 impulses. What is the weight of this impulse? 1. So del of tau plus 2. This has negative weight minus del of tau minus 2 d tau. This is a standard relation. U of t is integration of impulse running integral. So based on that, this is u of t plus 2 minus u of t minus 2. Once you draw that graph, it is a rectangle extends from
minus 2 to 2. So, it is expected how to write this answer in terms of rectangle. So, we can treat that as rect T by 4 having amplitude 1, width of 4 units, very simple. What is the step response of the system? Integration of impulse response is called as step response. Let us see the next model. CTFT does not exist for Fourier transform is not defined for unstable signals. First one is a two-sided exponential. We have a standard formula. E power minus a mod t is having spectrum as 2a by a square plus omega square, two-sided exponential, standard relation. So, that is 2 into 2 by omega square plus 2 square, its Fourier transform exists. Second one is a growing exponent, e power at u minus t. For this also we have predefined relation. E power at u minus t is 1 by a minus j omega, Fourier transform exists. So, for option B we can say that as 1 by a minus. Of course, third one is a unbounded function, growing. Fourier transform does not. So, it is unstable signal for which Fourier transform is not defined. Last option is a decaying exponential for which the Fourier transform 1 by a plus j omega is the standard relation. So, Fourier transform is not defined for unstable signals. Option C. Let us see the next model. The Nyquist rate of an analog signal for alias-free reconstruction is, he has provided Nyquist rate 5000 samples per second. For a signal xt equals to g square t, what is the Nyquist rate? Nyquist rate of g of t is mentioned to be 5000 Hz samples per second. Indirectly, 2 times Fm is 5000. So, Fm will be 2.5 kilohertz, 5000 by 2, 5000 by. What is the meaning of g square t? Multiplication in time domain means Fourier domain, the spectrums are convolved. This is GF convolved GF, because this is indirectly GT into GT. Respective spectrums are convolved. Just for understanding purpose, if I am assuming G of F spectrum, reference spectrum like a rectangular spectrum that has highest frequency of 2.5 kilohertz, band limited spectrum. Indirectly you are convolving the rectangle with itself. Indirectly you are convolving the rectangle with itself. So, that is producing a triangular spectrum having its highest frequency as 5 kilohertz, having its highest frequency as 5 kilo. So, what is the maximum frequency for x of f? Maximum frequency of x of f is 5 kilo. So, what is the Nyquist rate of xt? What is the Nyquist rate of xt? 2 times 5k, 2 times 10 kilo, indirectly 10,000 samples, 10,000. So, what is the question asked? The Nyquist rate of analog signal for alias-free reconstruction is 5000 samples per second. He has provided Nyquist rate for us, 2 times Fm, 2 times highest. Indirectly, highest analog frequency for G of t is how much? 2.5. For understanding purpose, suppose I am assuming the reference spectrum something like this. G of f convolved G of f, because multiplication in time corresponds to convolution of respective spectrums. That is showing the highest frequency as 5 kilo. 2 times that number is Nyquist. Okay. Let us observe the Next model. The input of LSI system is given, output of LSI system is also given. He is expecting this quantity. He is expecting this quantity. So, what is the input data given? 6 minus 3, 4 minus 2. So, that is having index 0, 1, 2, 3. What is the output given? 48, 0, 20, 0, minus 8. So, that is having index as what? 0, 1, 2, 3, 4. Generally, when the input has m number of samples, system length is n number of samples, we know output length is what? M plus n minus 1 samples. So, what is m number here? Here we have 4 samples. What is output length? 5 samples. Okay. H of n length must be, length of h of n must be n number of samples. N number of samples. Here input has 4 samples, output length is 5 samples. So, 4 plus n minus 1, so n must be 2 samples. N must be 2 samples. Assume the unknown samples h of n as AB. 2 unknown samples we are assuming AB. Why? What is expected in the question? 2 into H1, impulse response at 1 plus 3 into X2, 4 into Y3. Luckily, X2, Y3 are visible for us. H1 is unknown. H1 is, that we have to find. That we have to, what is H1? It is nothing but B number. Let me solve in the next slide. 6 minus 3, 4 minus 2. X of n data is 6 minus 3, 4 minus 2. H of n is assumed to be AB. H of n is assumed to be, if you take product, 6a minus 3a, 4a minus 2a. Next, 6b minus 3b, 4b minus 2b. What is the output mentioned? What are the output numbers? 48, 0, 20, 0, minus 8. Okay. 48, 0, then 20, 0, minus 8. So, by comparison, minus 2b is minus 8. That means b is 4. Minus 2b is minus 8. We are expecting H1. What is H1 here? B. B is 4. Okay. B is 4. So, let us decide the final result. So, B is 4. Indirectly, H1 is 2 into 4, 3 into X2. What is X2 sample here? What is X2? Plus 4 into Y3. What is Y3? 0. So, 8 plus 12. That is giving us the result as 20. Input data given, output data given, system data is unknown. Input length m samples, system length n sample means we are aware output length is m plus n minus 1 samples. So, system has 2 unknown samples. By assuming AB, follow sum by column method, try to get the result. Here A is anyway not required. Of course, A is 8, not required for us. Minus 2B is minus 8 means B is 4. Find out the required quantity. Okay. Very simple. Let us see the next model. Consider the 4-point DFT of x of n. X of k is given. What is the DFT of x star n? Property. X star n DFT is nothing but x conjugate of minus k. Of course, it is circular reversal. Indirectly, it is x conjugate of n minus k. Periodicity of 4 sample. So, how to write that? X conjugate of minus k. Origin sample remains same, rest of the samples are that is x minus k, but for that conjugation, from xk write x minus k, origin sample remains same, rest of the samples are flipped. For that conjugation means 4 minus 2j 0 for that conjugation. So, option property based. X star n means x star of minus k. X star n means x star of minus k. Very simple. First you calculate x minus k, later on take conjugation. Based on periodicity, x star minus k is also equivalent to x star of n minus k, n equals to 4. N equals to 4. Okay, let us see the next model. Laplace. What is the Laplace of this function with ROC? Standard formulas. E power minus at ut is having Laplace transform as 1 by s plus a with ROC sigma greater than real part of minus a. Second relation, e power at u minus t is having Laplace as minus 1 by s minus a sigma less than real part of a. Standard relations. So, for the given function, what is the Laplace of the first term? We can write 1 by s plus 3 for which sigma greater than minus 3 is the ROC. What is the Laplace of the second term? We can write left sided function opposite sign plus become minus. Minus 1 by s minus 2 sigma less than. When we are in a position to add the individual Laplace expression, if we have common ROC, for the first term ROC greater than minus 3, second term it is less than 2. So, simply we can add them because common ROC exists. 1 by s plus 3 minus 1 by s minus 2 with the intersection ROC lying between minus 3 to do simplification. S plus 3 into s minus 2, numerator it becomes s minus 2 minus s minus 3 minus s. So, overall it becomes minus 5 by s plus 3 into s minus 2. Common ROC lies between minus 3 to 2. Okay, very simple. Based on the standard relations, e power minus at ut Laplace is what? 1 by s plus a sigma greater than real part of minus a. E power at u minus t means minus 1 by s minus a sigma less than real part of a. So, for adding the respective Laplace expressions, we have to check whether common ROC exists or not. Whether common ROC exists or not. After simplification, we got that result. S minus s cancellation here. Okay. Let us see the next model. This is also a property, accumulation property of jet transform. What is the jet transform of accumulator? See, accumulator is nothing but sigma minus infinity to n x of k. For your understanding purpose, I am writing this as x of n convolved with minus infinity to n del k. Any signal convolved by impulse replicates the signal. This is nothing but our un. This is nothing but our un step sequence. Convolution in time domain is multiplication in z domain. So, it is xz into u of n standard jet transform is what? 1 by 1 minus. It is a property, accumulation property. The given summation can be written as what? X of n convolved summing point. So, convolution in time is multiplication in z domain. For x of n, it is xz. This is un. U of n unit step sequence standard jet transform is what? 1 by 1 minus z inverse. So, very simple. Xz by 1 minus z inverse. Xz by 1 minus z inverse. Let us see the next one. What is the time period of this function? See, those functions are individually periodic. Normally we are aware e power plus or minus j omega naught t is periodic for any choice of omega naught. But when we are adding them, we are expecting GCD, harmonics concept. First time you can feel that the frequency is 4, second time the frequency is 3 pi, because it is looking like what? E power j omega naught t plus theta. Can you take the GCD of the given numbers like harmonics concept? They are individually periodic. First signal is periodic, second signal is also periodic individually. But when we are adding the periodic functions, how to observe the time period? If you calculate fundamental frequency, automatically you can calculate time period. 2 pi by omega naught. It is GCD of the given numbers, which is not possible. So it is a non-periodic function. Combinedly it is non-periodic. They are individually periodic, but combinedly aperiodic or non-periodic. Let us see the next model. If x1t and x2t are two periodic signals, yt is x1t convolved with x2t. This is like periodic convolution concept. They are having Fourier series coefficients AK, BK. So normally what is exponential Fourier series coefficient standard relation? If you feel x of t, of course it is mentioned as x1t here, the exponential Fourier series coefficient as AK. What is the standard relation? 1 by t integral 0 to t x1t e power minus j k omega naught t dt. That is the exponential Fourier series coefficient definition. Similarly, BK relation. So, when they are like periodic convolution concept, convolution in one domain is multiplication in other domain. Once you apply the Fourier series property, it is assumed to be the time period as t naught according to the given options. The respective spectrums are multiplied. Extra t naught you will get. Extra t naught. Based on the proof of that respective property. Convolution in one domain is multiplication in other domain. So, convolution in time domain. So, it is multiplication of the spectrum. T naught into AK, BK. Very simple property. Okay, let us see the next one. What is the fundamental frequency of this signal? Fundamental frequency is again GCD concept. So, what are the frequencies given for us? Different frequencies here, 5 pi, another frequency 13 pi, another frequency 20 pi. Simply select GCD, 5 pi, 13 pi, 20 pi, simply pi. Fundamental frequency omega naught is pi. Maybe it is given in f scale, 2 pi f naught is pi, f naught is 1 by 2 hertz. It is given in. You are all aware, multiple signals addition means harmonics is our logic. N omega naught concept, n omega naught integer value of fundamental. So, in the example we have which harmonics? 5th harmonic, 13th harmonic as well as 20th harmonic. N omega naught concept. We have 5th harmonic, 13th harmonic as well as 20th harmonic. Calculate omega naught, that is simply pi. Omega naught expansion is 2 pi f naught. Solve for f naught, that is 1 by 2 hertz. Very simple. Fundamental frequency is asked. Fundamental frequency. DC is an exception when it is added with a periodic function. Let us see the next model. What is the impulse response of the following difference equation? To get the impulse response easily, better to apply jet transform concept. So, where we require some standard relations. One standard relation is a power n un jet transform. The predefined formula is 1 by 1 minus a z inverse. We are in need of using time shifting property. X of n minus n naught jet transform is z power minus n naught into x z, time shifting problem. So, what is the jet transform of this expression? If you take jet transform here, 1 minus half z inverse, right side, xz into 1 minus 1 by 4 z inverse. So, what is the transfer function here? Transfer function is yz by xz, yz by xz. So, we can write that as yz by xz, 1 minus 1 by 4 z inverse divided by 1 minus half z inverse. Transfer function, calculate the transfer function, that is output jet transform by input jet transform. Just to split the terms, one term is 1 by 1 minus half z inverse, another term is 1 by 4 z inverse by 1 minus half. How to write the inverse here? Inverse jet transform is called as the impulse response, because generally jet transform of impulse response is system function or transfer function. What is this relation? Standard a power n un, a power n minus 1 by 4 times. What does this extra z inverse represents according to time shifting property? It is original jet transform into z power minus n naught. So, according to time shifting property, we have shift of one sample here. So, first you write the function 1 by 2 whole power n un, that is shifted by one sample, that is shifted by one sample. First you try to calculate the transfer function yz by xz. By applying z transform, we got this relation. So, what is the transfer function here? Yz by xz, this expression. Based on these standard formulas, we are in a position to decide the answer. 1 by 1 minus a z inverse corresponds to a power n un. Here extra z inverse is representing shifting of one sample. So, which is the correct answer here? 1 by 2 whole power n un minus 1 by 4 into 1 by 2 whole power n minus 1 u of. Very simple question. Okay. All the best.
Questions from digital electronics and microprocessors. Following statements, which of the following statement is incorrect? Okay, incorrect statement. Flip-flop is to store 1 bit, it is a correct statement, but we need to select incorrect statement. Race around condition occurs in JK flip-flop when both the inputs are 1s, J1 and K1, along with clock of course. Transparent latch consists of D type. D flip-flop means it is a transparent latch, of course, right? By look at the statement you can understand, but is given that master slave store 2 bits. No, master slave, this combination is again acting as one flip-flop. It is also a JK flip-flop, but actually master slave configuration is preferred to overcome the race around condition. So, flip-flop is a 1 bit storage device, that is all. So, 2 bits has given, so it is a wrong option. That means select the option C. It is a wrong statement, that is why option wise it is correct, because we need to select incorrect statement. Na? Yeah, how many bits are required to DAC so that its full scale output? Just recently we have solved this question, model, temperature range, almost the model is same. Full scale voltage is given, full scale voltage 10 milliamperes and its resolution less than like 40 microamperes. You take delta or otherwise resolution whatever, that is equals to 40 microamperes. So, is asking that bits. Of course, we will get some range of bits, we will take that within the range minimum value. Okay. So, what is the formula? Resolution is equals to full scale voltage by the steps, So, that 2 to the power of n minus 1, or otherwise you just take the steps, no problem. As the question is repeating, I am directly writing these steps. It can be greater than or equals to, just you write equal is equals to full scale voltage 10 milli divided by 40 micro. If you calculate it, this value you will get around 250. You verify it, 250. If this is 250, 2 power n minus n whole value minus 1 should be greater than 250. So, n value can be anything, it can be 6, 7, anything, it should be greater than 6. 6 is a greater than or equals to 6, 6 is the correct option, but do you have 6 here? No. 7, 8, 10, 20, 1000, anything, but the best value 7, right. We will go for the next problem. In which of the following number system 132 is not a valid number? You know, if you find certain number system, what is the condition? The symbol value, whatever may be the highest value, should not be greater or equals to radix, that is all. It should not be greater or equals to radix. So, if you take 132 here, the R value can be anything which is greater than 3. It should not be equal or less than 3, that is all. So, that 16, 10, 8 are correct. It cannot be 2 radix. So, that is asking about which of the following is not a valid number. So, that base 2. D is the correct option for this question. It is direct minimization based question here, xy whole bar dot this is y bar dot z, y bar dot z whole bar, but between these two inputs we have a common complement, means bubble. Apply De Morgan's theorem, xy double bar plus, again bar get cancelled, this is y bar z. Is there any possibility to minimize it? No, I think xy plus y bar z, xy plus y bar z, B is the correct option, got it. And very interesting question, in a octal number system 278 is added to y, x, some unknowns, 6 again octal number base 8, and the result is x, y, x, okay, this is x, y, x, then the value of y and x respectively. First we need to find y value and then x value. So, as per the given data 247 is added to y, x and 6, 2, 4 and 7 is octal number. If you want to convert it into binary, every digit should be represented in 3 bits form, right, octal to binary. So, then our conversion is easy or calculation is also easy. 247 plus y, this is y, x and this is 6, and he is saying that result is x, y and x, it is okay. Then we can write it as 0, 1, 0, 2, 1, 0, 0, 4 and 111 is 7, and this is y, we are adding these two numbers, okay, and this is x, and here 110, 6, and the result is what? X, y, x, this is x, this is y and this is x. Then you can do the calculation. What should be the result? We will see. 1 plus 0, 1 plus 0, 1, 1 plus 1, 0 with carry 1, 1 plus 1, 0 with carry 1, this is a carry, okay, and 0 plus 1 is 1. That means, what is the x value? 5. So, observation. From there, we can obtain x value as 5. So, first y and then x, y and x. Option C, directly we can find it because only one option is available, but it is okay. Let me do it. 1 plus 0, 1, this is 0 and 1 plus x is equals to y. Already you know x value is how much. So, from here again we can do the next step, 101, 101 plus what is the x value? 101. is equals to y. But wait, okay, you have to add them properly. So that you see, in place of x, here only I am taking this x value 1 0 1. Let me do it. 1 plus 1, I am writing y value now, okay, 0 with the carry 1. 1 plus 0 1. 1 plus 1 0 with the carry 1. This is a carry. That means what is a y value? 0 1 0. Don't fail. 1 5 plus 5 5 plus 5 10, right? It is 0 1 0, okay. So you can verify, you can cross check. So if it is 0 1 0 y value, this is what 0 1 1. See 0 1 1 and you place this 0 1 0 here. 0 1 1 means it is 3, 0 1 0 means it is 2, 3 plus 2 how much? 5. X value is how much? You know, 5, because it is a MSB bit, directly we can add it, okay. So finally y value can satisfy with 2. Let me verify 2 comma 5. C is the correct option. C is the correct option, right. Then no need, you can remove it, because we have done this here only. By taking this x value, substituting here, we can guess the next value. Coming to the next question, yeah, this is already completed, right. Halt state. By default, this is a halt state, right guys. In the circuit shown below, assume the initial data 0 0, then the states of the counter Q0 Q1 respectively. Immediately after the 112th clock pulse, what is the output? He is asking about the states Q0 Q1 respectively after 112 number of clock pulses. First of all, maybe 100 or 112 or 700 or 1000 clock pulse data if you want to find for a given counter. The simple point is, we need to identify the modulus number of the counter. You know, after modulus number of clock pulses, counter will automatically restarts from its initial state, as given initial state is 0 0. And there is one feedback here from the output of Q1 bar, and K of a first flip flop is permanently connected, second flip flop inputs are directly taken from the output of a first flip flop, okay, very simple. Let me take Q0 and Q1 here. While giving the initial data, we are not providing any clock. So this is the initial data. Let me write, instead of taking the separate table, I'd like to override the sequence, right, on that circuit. So what is this data? 0, and this is also 0. If this is 0, its complement is 1, okay. What are the inputs of first flip flop? Do not apply the clock, first you verify the inputs, 1 and 1. Now you think, what if a clock is applied? If a clock is applied, the first flip flop is going to toggle. At the same time, simultaneously, the second flip flop also will take that decision. Sir, why sir? Why? Because clock is given for both the flip flops from the same source. 0, then this is 1. Input of second flip flops are 0 1. So output will also 0 1, okay. So if I apply the clock, first flip flop toggle. So 0 toggle means complement of previous. At the same time, do not apply the next clock, okay. So at the same time, this 0 1 will transfer to the output of second flip flop. So again Q1 value will be 0. This is happened after first clock pulse. First clock pulse. Now update the data. 0. Next data is also 0 here. 0. So this is 1. So the next feedback also 1 here. But this is already updated, you know. What is the Q0 value? 1. So that updated data is 1. So this is 0. Now if you apply clock, what will happen? As again J value of first flip flop is 1 and K is 1. First flip flop will toggle, but this time second flip flop inputs are 1 0. After clock, output will be 1, okay. So that I am applying second clock pulse. If you apply the second clock pulse, what is going to happen? Same, first Q0 will be toggle, 1 complement 0, and same 1 will be transferred to the output. This is 1. Let me update the data. This will be 0 and this is 1, okay, and this is 1 and 0. Updated data is available. Now, you see what will happen if you apply the clock. What is this value? Q1 bar 0. 0 is available for the first flip flop. So, 0 1. If you apply clock, 0 1 will come to the output. Similarly, for the second flip flop also inputs are 0 1. So, very simple. 0 and 1 are the inputs for both the flip flops. The moment you apply the simultaneous clock, zeros will transfer. That means, if you apply third clock pulse, 0 0 will come, but the 0 0 is already the initial state. How many states available? 3 states. So, given is a mod 3 counter. So, this is a key point. After 3 clock pulses, every 3 clock pulses, counter will come back to its initial state, that is 0 0, right. But we need to find the sequence after 1 1 2, that means 112 clock pulses. So, you have to take the multiplication of 3 with some number, which should be an integer multiple of 112. Of course, 3 odd number may not be possible, at least you will get the nearest number. So, 37 times that of 3 is how much? 111, right? 111. So, what does it indicates? 37 times counter can restart from initial state. So, by that time counter value will be 0 0, but you need the output at 112. That means you add another clock pulse. After one more clock, 112, next state will come. After 0 0, what is the state? 1 0. 1 0 is the state. So, that I have taken Q 0 Q 1, he is also asking Q 0 Q 1. So, that answer is 1 0. B is the correct option. Got it? So, please verify the solution. I will go for the next question. See, how many minterms excluding redundant terms? If you find any repeated terms, you can ignore it in the minimal switching function of this. Here you should observe this point carefully. Given is a 5 variable function. There are different ways. For example, you can start like this: V, W, X, Y, Z. For example, we have only X, Y. That means what? V is missing, don't care. W is missing, don't care. X is available, I am taking small x just for reference. Otherwise, you may confuse it as don't care or X, okay. X, and then Y is also available, Y, and then Z. Z is not available here, Z is missing, so that you take missing variable as don't care. We have X and Y, that means this is 1 1 appeared as minterms 1, right. So, don't cares can be considered as zeros and ones. You take all possible combinations, 000 to 111, you will get some minterms. Similarly, here also if you do, you can find the repeated total number of minterms. If you find any minterms, you can remove them. This is one method. And alternative method is, I am using K map, okay. You take a 5 variable K map. So, we need to take 2 4 variable K maps, you know, and you also know that how to map them. So, what is the MSB bit here? MSB bit is V. I can write it as V bar and V and the remaining terms WX, W bar X bar, W bar X, WX and WX bar, YZ, Y bar Z bar, Y bar Z, YZ and YZ bar. You should maintain the same sequence here also. So, this is the result in fact, okay. This is the result, XY plus Y bar Z is obtained. What might be the minterms involved? Simple, you just think in reverse, right. By taking a 5 variable K map, assume that after minimizing a function, this is obtained result. What might be the minterm have been like grouped or involved in the K map? That many number of actual minterms available in the original function, like that also we can think. This is an alternative method. In class generally we have discussed multiple methods, method 1, method 2, method 3, and this is actually the method 2 from the class notes. Okay, let me take this XY. How can I get XY? Look at this man. This is x. How can I get x, y as common? This is y. If I take the minterms here, I can get, you see, common term x, y, but it is not xy, xy dot v bar. But we have only xy, we don't have v bar. How can you overcome the v bar existence in the result? You take the same copy into the next K map, because it is 5 variable K map, okay, like this. Next, what is the next answer? I mean, next minterm in the result, y bar z. It is directly available, you see, y bar z. If you take this minterm, this is going to be y bar z into v bar. I want y bar z only, so that you take this here in the second K map also, like this, y bar z over. If you group this K map, you will get this answer. That means this is a question. This question is nothing but standard SOP function, in which you can find the number of minterms. How many minterms are available? 4 plus 4, 8, 4 plus 4, 8, right? So that total 16. Total 16 terms are available. Option A. Option A is correct. Let me go for the next question. A temperature in the range -40 to 55 degrees is to be measured with a resolution of 0.1. Of course, resolution may be volts, may be milliamperes, maybe degree centigrade. In this experiment, has given the resolution 0.1 degree centigrade. Of course, the minimum number of ADC bits required to get required to match the dynamic range of a temperature sensor, right. So, just you remove this, required to get a dynamic range. So, we need to match the number of bits, right, without any shortage of bits in order to get this accuracy. And actually the project range of temperature is -40 to 55 degrees. Actually the we have a resolution here, you know, a formula between the resolution and the number of steps. So, number of steps is equals to full scale voltage. Full scale voltage, or we can call it as range, strictly speaking, generalized formula, range by resolution. Range by resolution, or otherwise resolution equals to full scale voltage by number of steps 2 power n minus 1. I think you may remember, in general we are doing that, right, with a voltage, but here we have doing with temperature. So, first of all, you need to identify the range of temperature. What is the range of temperature? 55 minus 40 degrees. So, 95. This many number of stages of temperatures we can see, -40, like or plus 55, plus 54, or 0, or 1, like that, totally 95. Number of total range is 95. Then you can directly substitute it. So, the steps formula you know well, 2 to the power of n minus 1 is equals to, what is the range? 95 divided by, what is the resolution? He has given that, look at this, 0.1. So, 2 to the power of n minus 1 is equals to, or maybe greater than or equals to, we can write while finding the n value. Even if you use more number of bits, no problem, but there should not be a shortage of bits for the given experimental result. Okay. So, this is equals to 950, 0.1, okay, 950. So, that 1 by 10. So, 2 to the power of n should be greater or at least equals to 951. If you take n value as 9, 2 to the power of 9, 2 to the power of 9, 512. So, not matching, it is not sufficient. If you take 10, that will definitely matches the range, because even there is a shortage, even there is a excessive value, no problem, there should not be a shortage value. So, that, sir, 12 and 14 also correct? Of course, you should match it, at the same time you should select the minimum number of bits. Okay. So, in all aspects we can select option B. So, we need 10 bits for this given ADC, then only it can match with the given resolution, right. In the given circuit, find the frequency at output Y naught. This is the direct question here, but actually you see, please observe it carefully. This is actually a counter, okay. It is not single flip flop, it is a counter. Direct 4-bit Johnson counter, input and output is given. Sometimes they can give you this type of symbol also, no need to worry, okay. So, for this counter, we have 20 megahertz of input. What is the output frequency of a counter? Generally, input frequency divided by modulus number. But if two counters are connected, see, this is a toggle switch. Toggle switch means it is a mod 2 counter. What is the modulus number of Johnson counter? 2 into n. What is the n value? 4 bit, 2 into 4, 8, okay. So, that you can find, you see here you can find the frequency, input frequency 20 megahertz divided by 8, 2.5, right, 2.5 megahertz, right. Then what is the output here? This input frequency divided by its modulus number, 2.5 megahertz by 2, 1.25 megahertz. So, it is a direct question, 1.25 megahertz. B is the correct option, right. And find the output Y naught, very simple and straightforward question. Active low enabled type controller is connected to ground, means this multiplexer is in active state. So, what are the values of information lines? I naught is equals to I1, you see these two are connected, okay, like this. I naught I1 is equals to 0. I2 value 0 complement, I3 also 0 complement. I2, I3 value is 1. S1 is permanently connected to complement of 0, that means 1. So, what is a Y naught? S1 is 1, we cannot change it. Generally, what is the expression? Y naught is equals to S1 value is 1, okay, 1 into B. B can be either 0 or 1. B is a variable, but S1 is no longer a variable, it is just a 5 volts or logic 1. So, that 1 into B bar. So, that 1 into B bar plus 1 into B. So, that means what? 1 0 pin number 2 and this is 1 1 pin number 3. 1 1 means pin number 3 and this is pin number 2. So, what is the content of pin number 2? Content of pin number 2 is 1. Pin number 3 content also 1. So, that you can write, or otherwise you can write in terms of B also, no problem, okay. So, B bar into 1 plus B into 1 into 1. So, what is the Y naught? B plus B bar value is 1. In that way also output will be fixed at logic 1. So, B is the correct option, right. Output is always 1. Next, this is the standard question here, S1, S naught value of 8085 microprocessor or 0, it will shows the halt state, right.
Analog circuits. So, please go through the question. Find the average power dissipated in the 30 ohms resistance where the diode is ideal in milliwatt, right. Mind you, the units here is in milliwatt, okay. The diode is treated as ideal and you are asked to find the power dissipation in the 30 ohms resistance. So, what is the power dissipation formula? Power dissipation is IRMS square into R. And what is IRMS for half wave rectifier? For half wave rectifier, IRMS equal to IM by 2. IM by 2. So, let us find IM first. For finding IM, what is the peak input voltage? The peak input voltage Vmax is 10 volts. So, what is Im? Im is going to be 10 by 10 plus 30 plus 20, which is 1 by 6. So, let us substitute here 1 by 6 by 2, it is 1 by 12, 1 by 12. So, what is IRMS if we substitute? IRMS is 1 by 12 whole square into 30 ohms. So, this is the solution. So, let me use the calculator. So, it is 30 divided by 12 square, 144. It is 208.3, 208.3. The units of power is watt, milliwatts. So, I repeat, this is a half wave rectifier. You are asked to find the power dissipation, and we know the power dissipation formula is IRMS square into R. And what is IRMS for a half wave rectifier? It is Im by 2, Im by 2. Now, go through the question. The frequency of oscillations generated by the circuit in hertz. So, this is a standard stable circuit, and if this is R and this is C, and here you have R1 and R2, the time period is given as minus 2 RC log R1 by R1 plus 2 R2. So, this is a standard formula. So, if you want, we can derive this also, but this is a very standard formula. So, let us substitute minus 2, R is 1K into 1 micro log 10K by 10K plus 2 times of 10K, 20K. So, it is going to be 2 milli log. So, I will remove the negative sign, 1 by 3 becomes 3. So, it is log 3 is already given 1.1. So, 2 milli into 1.1. So, this is the time period, but we are asked to find the frequency. What is the relationship between time period and frequency? F is 1 by t, 1 by t. So, it is going to be 1 by 2 milli into 1.1. So, let us calculate this. 1.1 into 2, 2.2, 1000 divided by 2.2. 454 I am getting, 454.5. So, it is 455, option B. The units of frequency is hertz. The units of frequency is what? Hertz. So, let us go through the next question, or you can as well derive this. What if this plus V is say plus 10 volts, minus V is say minus 10. Then this voltage, if this is plus 10, you will have plus 5. If it is minus 10, you are going to have minus 5 by voltage division. So, if you want, you can, the output is going to give you a square wave between plus V and minus V, plus V and minus V. So, what happens here? This capacitor is going to charge towards plus V, but when it crosses V by 2, then if the voltage at inverting is more than non-inverting, the comparator, the output will flip from plus V sat to minus V sat. So, similarly, in the negative side, this is going to be minus V by 2.
So, if the whole duration is t, then half of it is going to be t by 2. So, how do you find? The voltage across a capacitor for all time is V initial minus V final, which is plus V, e power minus t by tau, tau is RC, plus V. At time t equal to t by 2, you are going to land up at V by 2. So, from minus V by 2, you are going towards plus V. So, what happens at V by 2? V by 2 is minus V by 2 plus V e power minus t by t is t by 2 RC plus V. So, from here you can find t. T is going to be minus 2 RC log 1 by 3. So, like this also you can solve. An inverse of time period will give you the frequency. Go through the question. For an NPN transistor, the current gain alpha of the transistor is equal to 0.996. If the value of collector to base leakage current when emitter is open is ICB0, then the value of collector to emitter leakage current when the base is open. So, this is a simple substitution problem. ICE0 equal to 1 plus beta times of ICV0. But what is beta? Beta in terms of alpha is alpha by 1 minus alpha into ICV0. So, let us substitute 1 plus alpha is 0.996 by 1 minus 0.996 into ICB0 is nano, 2 nano. Nano is 10 power minus 9. So, you can use the calculator now. Uh, 0.996, 1 minus 0.996, 0.996 divided by 0.004 plus 1, 250 into 2 is 500 into 10 power minus 9 I am getting. So, we want this in micro, so it is 0.5. Now, this volt is wrong here, this is the correct answer. The answer is in micro. Now, go through the question. For the transistor circuit shown, VB is 0.7, beta is very high, then the value of V0 in volts. So, you are asked to find V0 here. VB is 0.7 volt. So, this is going to be minus 0.7. So, what is the current here? Minus 0.7 by 1K minus 0.7 milli. So, the total current here, emitter current, is the summation of these two currents. 2 milli minus 0.7 milli is 1.3 milliampere. So, this current is also 1.3 milli. Since beta is large, emitter current and collector current both are same. If 6 milliampere is flowing here, this is 1.3, then this should be 4.7 milli. So, what is 4.7 into 1K? 4.7 volts. So, this is the right answer. So, first we have found the emitter current, the emitter voltage, then the emitter current. Emitter and collector current both are same. because the beta is given very high, right. For the op-amp circuit shown, calculate the output voltage. Calculate the output voltage. So, how will you solve this problem? Okay, so here you can see there is a current source. This current is split into two currents, I1 and I2. And this potential and this potential both are same. Suppose this node is Vx, this node is Vy. So, this is also Vy. So, you can see Vx minus Vy is this drop, Vx minus Vy is this drop. So, the voltage across this and the voltage across this both are same. So, what is the total current? The total current 1 milliampere equal to I1 plus I2. And I1 into 2K equal to I2 into 3K equal to Vx minus Vy. So, or if you remember current division formula, you can directly use it without solving. So, if you solve it, you will get I1 equal to total current into opposite arm resistance by sum. So, this is 0.6 milliampere. Then I2 should be 0.4 milli. So, let me check 4 3s is 12, 6 2s is also 12. So, this drop and this drop both are same. Now, since this node is Vy, this is also Vy, the difference is 0 and this current is also I1, this is also I2 and you are asked to find V0. You are asked to find V0. Now, how do you solve for V0? You can apply KVL if you wish like this. So, KVL minus I1 into 1K plus 0 plus I2 into 4K plus V0 equal to 0. So, I1 is 0.6, I2 is 0.4, 4 4s are 1.6 minus 0.6. So, your V0 is minus 1 volt. So, you can substitute I1 and I2, V0 is minus 1 volt. And if you wish to calculate Vy, Vy is I1 into 1K. If you wish to calculate Vx, it is I1 into 2K plus 1K, if you wish to calculate. Now, this is a current mirror circuit. In this circuit, Q1 and Q2 are matched transistors with VB is 0.7, beta is 50. Then the value of I1 by I2. So, how will you solve this? Now, since VBs are same, their IC should also be same. If this is IC, this is also IC. So, the base current is going to be IC by beta. This current is also IC by beta. So, the total current is going to be 2 IC by beta, because entering current is leaving. So, what is I1? I1 is IC plus 2 IC by beta. It is IC, IC is nothing but I2, IC is nothing but I2. So, the question is find I1 by I2. I1 by I2 is 1 plus 2 by beta. Beta is 50. Beta is 50. 1 plus 2 by 50. So, it is 52 by 50. It is going to be 52 by 50. So, what is 52 divided by 50? It is 1.04. Option B is the right answer. Now, go through this problem. This is a Wien bridge oscillator. It is a standard circuit. The value of R required for the sinusoidal oscillations of frequency 1 kilohertz is. So, for a Wien bridge oscillator, what is the oscillating frequency? F equal to 1 by 2 pi RC. But you are asked to find R, which is 1 by 2 pi FC. 1 by 2 pi, F is 1K, 10 power 3. C is 1 micro, 10 power minus 6. So, it is 1 by 2 pi kilo ohms. It is 1 by 2 pi kilo ohms. Option D is the right answer. Simple formula, a standard Wien bridge oscillator. An amplifier has an open loop gain of 10, input impedance of 0.5 kilo ohm, output impedance of 200 ohms. The feedback network with a feedback factor 0.9 is connected to the amplifier in a voltage series feedback. The input and output impedances are. So, what is the desensitivity factor? 1 plus A beta. A is 10 and the feedback factor beta is 0.9. It is 10. Now, since this is a voltage series feedback or series shunt feedback, input resistance should be input resistance of the basic amplifier multiplied by 10 times. So, it is 0.5 kilo ohm into 10, it is 5 kilo ohm. The output resistance is going to be output resistance of the basic amplifier divided by 1 plus A beta. The output resistance is 200 ohms by 10, it is 20 ohms. So, 5 kilo ohm and 20 ohms. Find Rx for sustained oscillations for the oscillator circuit shown below. So, you can calculate the loop gain and do it, or another simple shortcut technique is whenever an oscillator generates an oscillating frequency, it should be a parallel resonant circuit. So, this is a simple parallel resonant circuit. At the oscillating frequency, this LC acts as open circuit. LC acts as open circuit. So, when this is an open circuit, if this is V1 and V2, so what is loop gain? The loop gain is V1 by V2 into V2 by V1 is 1. V1 by V2 into V2 by V1 is 1. V1 by V2, this is a non-inverting amplifier, 1 plus 9K by 1K. V2 by V1, so this is V2. So, this network is an open circuit. You can apply the simple voltage division, 0.5K by Rx plus 0.5K is 1. So, this is 10, 10 into 0.5 is 5, Rx plus 0.5 is 5, Rx plus 0.5 is 5. So, what should be Rx? 4.5K. 4.5 kilo ohm. for a class A FET power amplifier with 10 volts drain voltage, 10 volts drain voltage, and 2 ampere is the current drain current bias, providing RF load current of 1 ampere amplitude. What is the efficiency for the load resistance of 5 ohms? So, here when they say efficiency, they want you to find the power efficiency. So, what is the power efficiency formula? Power output by the DC power into 100. What is power output or power DC? PDC equal to V into IDC. The VDD is 10 volt, IDC is 2 amp. So, it is 20. What is power AC? It is IRMS square into RL, which is IM by 2 square into RL. Because IRMS is IM by root 2. So, root 2 square is 2. IM is not, IM is given 1, 1 square is 1 into 5, which is 2.5 ohms. So, let us substitute now. Power output by power input, 2.5 divided by 20 into 100%. So, let us calculate this. So, it is 2.5 divided by 20 into 100%. So, let us calculate 2.5 divided by 20 into 100. It is 12.5, 12.5%. 12.5%. So, now let us go through the last question. Last question, consider the MOS circuit as shown below. ID current is constant and VDD is variable. Choose the correct variation shown in the plot. So, now this ID is given as constant and this VDD is nothing but VGS or VDS. So, choose the correct variation in the plot. Where is the plot? So, here you can see the plot is between VDD and root L. So, how VDD and root L vary, we have to look at the drain current equation. ID is K times of VGS minus VT whole square by 2. So, it is K by 2, VGS is VDD minus VT whole square is ID. So, what is VDD minus VT? It is 2ID by K under root, or VDD is VT plus ID is constant. So, you can take this whole value as constant. And here what is K? K is mu Cox W by L, mu Cox W by L. So, if mu Cox and W is also constant, then you can see that this VDD is equal to this VT, I will call it C1, and this whole factor as C2 into root L. So, this is of what form? This is of the form y equal to mx plus c, mx plus c, y equal to mx plus c. It is a straight line. So, in this 4 options, option B is a straight line. Okay, thank you.
So, let us see the questions from the communication systems. All are objective. Remember, you cannot use the calculators. So, try to solve without using calculator to the maximum extent possible. Okay, very good questions I have taken. These are the sample models. See here. a receiver is tuned to 550 kilohertz. That means Fs is 550 kilohertz. And the corresponding local oscillator frequency is also given, means FLO is equal to 1010 kilohertz. What are IF and image signal frequencies? So what is your IF? It is always the difference of local oscillator frequency and a tuned station frequency, which we will keep it as constant. So 1010 minus 550 kilohertz, how much you will get? 460 kilohertz over. Just the difference between those two. Okay. So if you see your options, obviously only one option is having 460, so you can straight away go with your option A. However, what is the image signal frequency? Generally we write image station as FIM. It is a tuned station frequency added with a 2 into intermediate frequency. This is the formula. So what is Fs here? Fs is 550 kilohertz tuned station frequency plus 2 into this value, 460 into 2 will become 520 kilohertz. Add these two values. So what is this value you will get? 0, 5 plus 2 is 7 and 1070 kilohertz. So this should be the image station frequency. Sorry, this is a 2 into IF, right? 550, anywhere we missed? What is IF and what is FSI? FSI here in the sense is your image station frequency. So it will be Fs plus 2 into FIF. So 460 plus 460, this is, sorry, this just I'll change it. Be very careful with your numerical calculations, okay? This is 920. So when you add these two, 0, 5 plus 2 will become 7, 5 and 9 is 14 kilohertz, that is the answer, okay? So we got 1470 kilohertz. Don't use calculators. Calculators are not allowed for this exam. Be careful. Next. See this one. The waveform S of t is given as an input to a matched filter. Which of the following waveform shows the correct output of a matched filter? So what is the impulse response of a matched filter? It is a S of TB minus T. What is a TB? TB is the bit duration of your given input signal, which is a capital T seconds in our question. So this value should be S of T minus capital T. Means what is the meaning? When you sketch this response, what is the impulse response of the filter? Invert the signal with respect to origin and shift it right side by T times. So again will you get the same function or not? So what we are getting? We are again getting a function from 0 to capital T whose amplitude is A. That's all. So this is representing the impulse response of the matched filter for the given input signal S of t. Okay. So what is the output of the matched filter? The output of the matched filter will be this S of t convolved with H of t. Now here you have to check with your options. What is the data you can use? You are doing convolution of two signals having equal width. Now use these logics. Convolution output means y of t exists from sum of lower limit of two signals to sum of upper limits of two signals. So it exists from where to where? Sum of lower limits is t equal to 0 to sum of the upper limit means t plus capital T. It should be 2t. That is the first point. Now, what is the second point? When you are doing convolution of signals of equal width, shape will be triangular. So y of t is a triangular waveform. Is it correct or not? Now, what is the total area of the convolved output? Third point that I am using here is integral y of t dt. This will be always equal to product of areas of two signals involved in convolution. So what is the area of the first signal? it is like base into height, capital A into capital T. And area of the second signal is also capital A into capital T. So when you take the total area of the convolved output, it will be product of areas of two signals, A square into T square, finish. Now using these three, you can easily match your answer. That is how questions will be framed in your exams. Okay. Now see your options given. These are the options. So what is the shape? It is a triangle. And from where to where? 0 to 2t. So you see those options, you can eliminate the first answer. You can also eliminate the second option. Now this is from 0 to 2t, so possibility is there. Now whether the total area is a square t square or not, check it. What is the total area? This is one right angle triangle and this is one more right angle triangle. Means half into base is capital T, height is capital A into capital T. Same triangle is repeating again, so you multiply with 2. So you are getting a capital A into T square. But our requirement is A square into T square, remove it. Now you go with option D, 0 to 2t, perfect, triangle, perfect. What is the total area? Half into base is capital T, height is A square T. Same triangle repeating once again, multiply with 2. So you will get A square into T square. Is it perfectly matching or not? So your choice should be option D. So if you know these points, that is enough. This is how you have to do this. Don't waste your time in doing entire convolution procedure. It will take a lot of time because these are time bounded exams. You have to be sparkling fast. Where it starts, where it ends, shape, area. These three are sufficient. Okay. Let's see the next bit. See this question. A broadcast AM transmitter has a carrier power of 50 kilowatts. That means power taken by the carrier component is 50K. If modulation is 100%, means mu is 1, perfectly modulated signal. Then total transmitted power means PT. What is the formula? PC into 1 plus mu square by 2. If nothing is given, you can assume that it is a single tone modulation. So what will be this value now? Power taken by the carrier component is 50 kilowatt into 1 plus 1 by 2. So 3 by 2 into 50K means 3 into 25, it becomes 75 kilo. That is the answer. So your option will be option C. Okay, straightforward question. See the next bit. A standard AM transmission sinusoidally modulated to a depth of 50%. So here he is talking about AM and sinusoidal modulation means message signal is single tone. That is the meaning. So what are the parameters given here? Value of modulation index 50% means 1 by 2 means 0.5. Under modulated signal. Produces sideband frequencies at 7 megahertz and 8 megahertz means FC plus FM is 8 megahertz and FC minus FM is 7 megahertz. The peak amplitude of each sideband frequency is 100 volts. Determine the amplitude and frequency of the carrier. So what is the amplitude and the frequency of the carrier? So he is asking about the frequency of the carrier first of all. So if you add these two, how much you will get? 2FC will become 15 megahertz. That means what is the frequency of the carrier component? It is 7.5 megahertz. Finish. That is the frequency of the carrier component. So out of your options, there are chances that B or C can be true. You can remove option A and option D. Now, what is the other component you have to find? You also have to determine the amplitude of the carrier. So what is he saying? The peak amplitude of each sideband frequency is 100 volts. That means what? In time domain expression, we will have AC mu by 2 cos 2 pi Fc plus Fm and AC mu by 2 cos 2 pi Fc minus Fm. So, the peak amplitude of this is given as 100 volts, equate it. So, AC mu value is 1 by 2, so I am writing as 1 by 4 equal to 100. So, what is the peak amplitude of the carrier? It becomes 400 volts. So, you will have 400 volts and 7.5 megahertz. That will be your right choice. So, whatever the amplitude he is talking here is from time domain expression. Do not get confused. Do not take your spectrum. So, this is the peak amplitude of your sideband in time domain. So, that coefficient you take and equate it. You will get the answer. Next, let us see the next bit. A random process x of t is passed through a system. So, here what is he doing? He is considering a random process. So, input is a random process x of t and the mean value of the input random process is 5. Now, the system that will be under consideration is an LTI system, because in your syllabus anyhow only these systems are there. Now, the system has a transfer function h of f which is equal to 2 into e power minus j into 10 omega, or you can write e power minus j into 2 pi f into 10. Okay. Now, whatever the output random process you get, let it be y of t. So, he is asking what is the mean value of the output random process, mu y. So, what is the relation we have? Mean of the output random process is always mean of the input random process multiplied by the value of the system function at f equal to 0. It tells about DC. So, that is the reason we will take the transfer function value at f equal to 0. So, what will be this value now? Mean at the input is 5 multiplied by value of h of f at f equal to 0 is 2. So, it becomes 10. That is the answer. Finish. Simple. Okay. Let us see the next bit. The power spectral density of a stationary random process is given. The power spectral density of a stationary random process is given. What is the power of the random process? So, this is a little bit a typical question. Typical question in the sense it is easier only, it may take more time. So, what you have to do, let us assume this omega square is replaced by a variable x. Then what is your power spectral density? You can write this as 10x plus 35 divided by x plus 4 into x plus 9. You are given power spectral density. So, you have to get the power. What is the logic you can use? Power is obtained as 1 by 2 pi total area of your power spectral density. This is the formula we have to use. That is what I am doing now. So, I have to take the area of this function. So, directly you cannot calculate area, na? So, first calculate or simplify it, then you can easily do it. So, this you can write it as a by x plus 4 plus b by x plus 9. Correct or not? So, what is happening? Coefficient of x is a plus b is 10 and constant term 9a plus 4b is 35. You cannot use calculator, so please do it. It is not a problem. Multiply with 4 and subtract from 2 from 1. So, 9a minus 4a will be 5a, 4b minus 4b becomes 0, 35 minus 40 will be minus 5. So, a is minus 1 and hence value of b will be 11. That is all. Clear? So, what we got now? If you replace again your x with omega square, what is the power spectral density we are getting? The power spectral density of this random process is a value is minus 1 divided by what you are having? X plus 4, x I am replacing with omega square. So, you are having a 4 plus omega square plus value of B, I got it as 11 divided by, you are having x plus 9, I am replacing x with omega square. So, you will have omega square plus 9 or 9 plus omega square. Okay. So, to get the power, what I have to do? I have to integrate this function and divide the result with 1 by 2 pi. So, 1 by 2 pi integral from minus infinite to infinite. I am writing this as minus 1 by 4 by 1 plus omega by 2 whole square d omega plus 1 by 2 pi integral from minus infinite to infinite 11 by 9 divided by 1 plus omega by 3 whole square d omega. Finish. Okay. So, what is the power of this random process now? 1 by 2 pi into, you can bring this minus 1 by 4 outside. This is like a tan inverse of integral 1 by 1 plus x square dx or not, tan inverse x means you will have tan inverse omega by 2 integrated in the interval from minus infinite to infinite. And in denominator you have to substitute its derivative, means 1 by 2 will come. So, that 2 will come in numerator. Plus, what is the second term? 1 by 2 pi. Again I can bring that 11 by 9 outside into, this becomes a tan inverse omega by 3 integrated in the interval from minus infinite to infinite. In denominator you will have 1 by 3. So, 1 by 3 will become 3 in the numerator. That is all. You get my point or not? So, what will be the total power now? It will be equal to, so this, when you integrate this function you will get pi by 2 minus of minus pi by 2 means you will get pi. Here pi is there into 2, 2 pi and 2 pi, 1 by 2 pi will get cancelled, minus 1 by 4 will be remaining. Here also same thing, you will get pi by 2 minus of minus pi by 2 means 1 pi. That pi and this 1 by pi will get cancelled and this 3 will go here 3 times. So, you are having 11 by 3 goes here 3 times, 3 into 2 will become 6, finish. So, LCM is how much? 12. So, you will have minus 3 plus 22 by 12. So, what is the total power? 19 by 12 in watts. So, little calculation you have to do, because calculators are not allowed, you cannot do the integrals very quickly. Just a simple max only, it takes time. So, your answer is 19 by 12, that will be your right choice. Otherwise, what you have to do after you get this power spectral density, you have to get, means after this you convert into autocorrelation and then take the value of the function at tau equal to 0. Both are correct, it is up to you. Let us see the next bit. This is also a little bit time taking but very good question. Model is very important. Consider a system shown x1 and x2 are occurring with equal probability, means what? P of x1 only 2 transmitters are there, so 0.5, and P of x2 is also 0.5. Okay. Now, what is he asking? What is P of x2 given y2? So, what is this value? Use the base theorem. It is P of y2 given x2 into P of x2 whole divided by P of y2. This is what you have to find. Finish. So, what is the P of y2 given x2? Probability of getting at y2 when transmitted from x2, conditional event. So, what is that value? You can see very clearly here. What is that value we have? Probability of getting at y2 from x2 means this line. So, what is that line probability you are given? It is equal to 0.6. So, this value directly is 0.6 over. And you also know what is P of x2. equal probabilities is given. So, it is 0.5. Now, what is P of y2? Probability of any value coming at y2. So, your destination is y2. So, from where you are getting? You are getting events from x1 to y2, and also you are getting event from x2 to y2, that is all. So, use both these cases. So, probability of generation of x1 is 0.5 and probability of x1 coming to y2 is this line probability, which is 0.25, plus probability of generation of x2, probability that x2 generated comes at y2, this line probability 0.6, finish. So, what is this P of y2 now? This is like 0.5 by 4, so you can write it as 0.125 plus this is 0.3. So, this value will be 0.425, finish. Now, you substitute in that. So, this will be equal to P of y2 given x2 is 0.6 into 0.5 whole divided by, what is this value? 0.425, finish. So, you can write that as 0.5 as 1 by 2, this will be 0.3 by 0.425. So, approximately you can check that 0.3, therefore, probability of x2 given y2 conditional event is 0.5 I am writing as 1 by 2, 0.6 by 2 will be 0.3 divided by 0.425. Okay. So, you can just check with the closest option possible, that will be your right choice. Okay. Next, see this is also based on conditional events only. Joint probability density function is given. So, f of xy is given to you. I can write this as 1 by 2 e power minus mod x multiplied by 1 by 2 into e power minus mod y. This comes on your practice only. It makes a lot of easier when you solve question in this way. So, joint probability I am expressing as product of marginal density functions, where x is taking values between minus infinite to plus infinite and y is also taking values between minus infinite to plus infinite. Okay, minus is here. Now, what is he asking? What is the probability of x less than or equal to 10 and y less than or equal to 1? That is what he is asking. So, what will be this value now? You have to take x from minus infinite to 10 and y from minus infinite to 1. So, whenever you take mod x definition, it is x for x greater than 0 and it is minus x for x less than 0. Very simple. So, what will be your result now? If you take a probability of x less than or equal to 10 and y less than or equal to 1, even if you take less or also it is same, because this is our continuous random variable, nothing will happen. So, I can write this as integral from minus infinite to 10 your f of x dx multiplied by integral on y from minus infinite to 1 f of y d. So, already I have split my joint density function into marginal density functions. So, use that logic. So, this will be equal to, you have 1 by 2 e power minus mod x. So, I am taking limit from minus infinite to 0. This value becomes e power x dx plus integral 0 to 10, now e power minus x dx. That mod x I am splitting for negative values of x and positive values of x. Clear? simple mathematics only, nothing special here. Now into 1 by 2 integral y is from minus infinite to 1. So, I am splitting again from 0 to minus infinite to 0. You are having e power y dy plus integral from 0 to 1 e power minus y dy. Finish. Is it clear? Just splitting into limits based on the given probability density functions. Okay. So, this if you split and write, it becomes clear or very simple. It is a simple mathematical calculation. Now, what will be this value? 1 by 2 into e power x integral is e power x. When you integrate from minus infinite to 0, you will get 1 minus 0 as 1 plus, when you integrate this function, you will get e power minus x by minus 1 into e power minus 10 minus e power 0, which is minus 1. E power minus 10, is it negligible or not? Very, very small value. So, what is happening? You will get minus of minus 1. So, I am writing it as plus 1. Okay, into 1 by 2. Again, value of the first integral is 1 minus, you will have e power minus 1 minus 0, correct or not? So, how you can write that one? E power 0 becomes 1. So, you can write this as 1 minus e power minus 1. Finish. Is it clear or not? This is 1 plus minus 1 into e power minus 1 minus 1. You take 1 minus common. So, it will become 1 minus e power minus 1. So, 1 plus 1 minus e power minus 1. So, what will be this value? This will become 2 by 2 is 1 into 1 by 2 into 2 minus e power minus 1. Finish. Okay. So, that e power minus 1 is like 0.306. You have to remember that. So, just I will show you the clarity. I am using a mobile for calculator purpose, but do not use, because you cannot use it. If you take a exponential value of minus 1, it is a 0.306. You take a subtraction from 1 and from 2 and divide it with 2. So, this value will come around 0.816. So, no need to use it, you can write directly 2 minus e power minus 1 divided by 2. So, that e power minus 1, if you remember, that is enough. So, like 0.816, you can see how clearly it is mentioned. So, that is how you have to solve. Be very careful with these type of questions. Very simple only, not very difficult. Okay. Let me take to the next question. See this. An analog signal is sampled at 60 kilohertz. So, sampling frequency is given 60 kilohertz or 60 kilosamples per second, and is quantized into 256 levels. So, when all the levels are equally probable, how many number of bits you require? You require 8 bits per sample for encoding purpose. The time duration of bit of the binary coded signal is dash. So, here you first find bit rate. Bit rate is n into fs. So, what will happen? You will get a 8 into 60, 480 kilobits per second. So, what is the bit duration? That is what he is asking. It is nothing but 1 by RB. So, you will get a 1 by 480 milliseconds, or into 10 to the power of minus 3. So, you can write 1 by 48 into 10 power minus 4. You can do the calculation, just take 1 by 48. I am using here just to make it very clear. You can just do it in your exam. Up to 2 decimal it is enough. 0.02. That means closest approximation will be 2.08 microseconds. Okay. Very simple numerical, nothing very difficult. You can easily do it. Bit duration is asked. So, bit rate by 1 by bit rate is nothing but bit duration, TB seconds. Next. A super Heterodyne receiver receives signal in the frequency band. That means the tuned station frequencies are in the interval from 1200 kilohertz to 1900 kilohertz. This is the range of your FS. It is required that the image frequency should be outside the received band. What is the minimum required intermediate frequency? So, first of all, what is the frequency of image station? It is a Fs plus 2 into FIF. Now, what is the condition? If you go with the minimum value of Fs and take its image frequency, this should come outside the band. What is the maximum range? 1900 kilohertz. That's all. That is the condition. That is what he is asking now. If it is required that the image frequencies fall outside the band, so it should cross or at least it should touch 1900 K. If it is greater than that it is much better. So, what is Fs minimum? We have 1200 kilohertz plus 2 into I am taking a minimum possible intermediate frequency such that the sum of these two values will be at least 1900 kilohertz or a value greater than that. That's all. So, you will have a 700 kilohertz divided by 2. So, therefore, the minimum intermediate frequency I have to use to overcome this problem of image frequency will be 350 kilohertz. That is the answer. Is it clear or not? Simple bits only. All these are straightforward questions that are coming in exams. But only thing is you cannot use calculator. So, you have to be little fast while taking your numerical. Okay. So, answer will be 350 kilohertz. So, these are straightforward questions that are coming in your exams and very easily you can attempt them. Most of the times it will be numericals. Theory related questions are very rare, but one or two maybe little bit heavy numerical. Okay. Those you have to solve with a little bit common sense, like e power minus 1, like e power minus 10 we got, you can neglect. So, such things if you can remember, pi value or root 2 value, 1 by root 2 value, root 3 value, these things will be helpful. So, these are all the questions in your mock 1 exam.
I will going to deal the questions which are related to the electromagnetics. Fine. So, here is a question. Half wave dipole, he said half wave dipole antenna is operating at a frequency of 20 megahertz. So, he is asking what is the length of the antenna. In the question itself it is said that it is a half wave. Half wave means length of the antenna is lambda by 2. So, you need to find out the wavelength lambda. Lambda is equal to C by F. One can immediately write, which is equal to 3 into 10 to the power of 8 divided by 20 into 10 to the power of 6, which is 30 by 2. This is 10 to the power 1. So, it is 15 meters. Wavelength is 15 meters, but it is said that the length of the antenna is a half wavelength. So, it is lambda by 2, which is 15 by 2, which is 7.5 meters. 7.5 meters is the answer. So, option B is the answer. Correct? Let us have one more question. So, here is a question. In free space, the electric field is given by, this is the electric field expression, volt per meter. The magnitude of the displacement current is. So, what is the displacement current, guys? So, the displacement current is JD is equal to dou D by dou T, which is equal to, it is said that it is a free space. So, what is this D value? Dou by dou T of epsilon naught into E. So, epsilon naught is a constant, you can take it out, epsilon naught into dou E by dou T. So, that means you need to differentiate this one with respect to the time. Fine. So, can I write down directly? So, which is epsilon naught into, what is the differentiation of this one with respect to the time? It is minus cos, it is a minus sine, minus 20 sine omega t minus 50 pi x into y cap. successive differentiation, you need to differentiate this one with respect to the again omega. Correct? So then what is the omega here? Anyhow, so what is this JD? JD is equal to minus 20 omega epsilon naught into sine omega t minus 50 pi x into y cap. He said magnitude only. So what is the magnitude? This portion, it is 20 omega epsilon naught. You need to find out the omega value. So it is said that it is a free space. If it is a free space, what is the velocity? Vp is equal to omega by beta. So which is equal to 3 into 10 to the power of 8. From here, you can find out the omega value. Why? Because on comparison, what is the beta here? It is 50 pi. Yes. So the omega is equal to 3 into 10 to the power of 8 into beta. So it is 3 into 10 to the power of 8 into beta. What is the beta here? It is 50 pi. So bring this omega and substitute here. So the magnitude of JD is equal to 20 into omega 3 into 10 to the power of 8 into 50 pi into epsilon naught value is 1 by 36 pi into 10 to the power of 8. Yes, 10 to the power of 9. So check out this value. This value will turn out to be, it is 8.3 ampere per meter square. So 8.3 ampere per meter square. Option C is the answer. Correct? Let us have one more question. Here is a question. In a rectangular waveguide of dimension A by B, the intrinsic impedance for the mode TE13 is 200 pi ohms. Okay. Then is asking what is the intrinsic impedance for TM13 mode. So he has not mentioned anything. So you need to consider it as a air field. So we have one formula, eta TEM is equal to square root of eta TE and eta TM. Correct? So what is given is for TE13 is asking for TM13. So from here you can write TM13 is equal to eta TEM square divided by eta TE13, which is equal to 120 pi whole square divided by eta TE13. So which is 200 pi. So check out this value. TM13 will be equal to 72 pi ohms. Correct? So option B is the answer. Fine. Let us have one more question. Here is a one more question. If B is given, B is equal to B naught into e to the power of kt z cap for the cylindrical region rho less than B, then the electric field intensity E is, fine. So you have to make, he has given the magnetic field and he is asking for the electric field. You can make use of what is called a Faraday's law. Fine. So there is a cylindrical region here like this. Inside the cylindrical region, so this is a cross sectional view one can see. So you need up to only the less than B. This is a radius B. So he is asking what is the electric field for rho less than B. So you can make use of this Faraday's law, closed line integral of EDL, which is equal to minus surface integral of dou B by dou T into dA. What is the differential area in this? So here Z is fixed. So the differential area dA is equal to, it is rho d rho d phi z cap. So bring everything and substitute there. So the electric field is like this, loop is also like this. Fine. So the magnetic field is changing like this in the z direction. So the electric field will be around that. So this will become, this integral will become E phi into dl, which is equal to minus surface integral of, differentiate this one, it is dou by dou T of B naught into e to the power of kt into z cap, dot product with rho d rho d phi z cap. Clear, guys? So you can bring this E phi outside. It's a contour. Fine. So differentiate this one with respect to the time and bring the things outside. So what is the differentiation of this one? Minus b naught into e to the power of kt into k into surface integral of rho d phi. So this is 2 pi into radius is b, which is equal to minus b naught into k into e to the power of kt. Separate out the variables here, rho d rho, it is d phi. So E phi into 2 pi into b minus b naught into k into e to the power of kt. This is rho square by 2. Rho limits are from 0 to b. Okay, and then phi here. It is a cylinder, right? So the phi limits will be from 0 to 2 pi. Substitute lower limit, upper limit minus lower limit. It is E phi is equal to 2 pi b minus b naught into k into e to the power of kt. Correct? So this is b square by 2, it is 2 pi. I will going to turn the page here. So the b phi is equal to, it is 2 pi, correct, into, see, b here and b here will cancel out, pi here and pi here, 2 pi will cancel out. Let me remove this part here. E phi is equal to minus b naught into k into e to the power of kt. So the 2 pi has gone. What is left is a b. It is b by 2. Correct? Yes. So here E phi is equal to minus b naught into b into k by 2 into e to the power of kt. Check out the options here. So it is a phi component. You can write this one in the vector form. So the E vector is equal to minus b into b k by 2 into e to the power of kt into phi cap. Clear, guys? So it is, you can check out the options here or adjust according to the options here. Minus 1 by 2 into b naught into k into b into e to the power of kt is phi cap. Okay, here in the place of b you are having the rho. It is said that rho less than b. Fine. So you can just substitute there. So E is equal to minus 1 by 2 into b naught into k into rho into e to the power of kt into phi cap. Okay, minus 1 by 2 into b naught into k into rho into e to the power of. So there is a k here. Option C is the answer. Clear, guys? Fine. So let us have one more question. A transmission line of Z0 is equal to 100 ohms is terminated in the line with the load impedance ZL. The VSWR of the line is measured to be 4 and the first voltage maxima is observed at a distance of lambda by 4 from the load. So then ZL is. So let me draw some rough diagram here. Here is a transmission line. This is having a load ZL and is connected to the characteristic impedance, let us say Z0. So at what distance? At a distance of lambda by 4, we are having what is called a voltage maxima. At this point voltage maxima is there, V maxima is there. So, we know that lambda by 4 length is an inverter. If it is a voltage maxima, at the load side you can expect what is called a voltage minima. Here is a V minima. And similarly, current will be reverse, quite opposite. So, here it is I minima and obviously here I max. So, ultimately it is asking what is the load value, fine. So, what you will be having at the load, ZL is equal to V minima by I max. This is nothing but a R minima, correct, whose value is equal to Z naught by rho, direct formula. So, if it is a R max, it is Z naught into rho, okay. So, what is the Z naught? It is the characteristic impedance, it is 100 divided by 4, which is 25 ohms. Let us have one more question. Here is a question. So, 25 ohms in the sense, what is the answer for this? Option C is the answer. Fine. Let us have one more question. Yes. So, assume a rectangular waveguide of cross section A by B, which is to be operated in the single mode, then determine the maximum value of B, so that the operating bandwidth for this mode must be maximum. So, there is some standard result here which you need to remember. Hope you people know this one. So, if you wanted to make the high dominant region in the waveguide, here narrow dimension B must be less than or equal to A by 2. It is asking maximum value. For maximum value, what you need to do? Maximum value for the B is asking. These two conditions, B less than or less than A by 2 or B is equal to A by 2 will both guarantee high dominant region width, but is asking a maximum value of B for which the bandwidth will be maximum. So, what is the maximum value of B? It is A by 2. So, here in this question you need to find out the broader dimension. What is given is a cutoff frequency for the dominant mode is given. So, what is the cutoff frequency for the dominant mode? From the formula FCTE10, which is equal to 1 divided by, nothing is mentioned, you have to consider it as a air field. So, to 2 square root of mu naught epsilon naught into 1 by A, which is equal to 5 into 10 to the power of 9. So, it is 3 into 10 to the power of 8 divided by 2 into 1 by A, which is equal to 5 into 10 to the power of 9. Clear, guys? So, from here you will going to get, you can check out this A value. So, the A value will turn out to be 3 centimeters. So, obviously, what will be the B value of this? B is equal to 3 centimeters by 2, which is 1.5 centimeter. So, what is the answer, guys, here? Option B is the answer. Correct? Let us have one more question. Yes, this is related to the antenna. So, a Hertz dipole having a length of 3 centimeters is operated at 1 gigahertz. If the efficiency is 0.6, then the loss resistance is. So, what is the efficiency? What is the efficiency formula for the antenna? Eta, it is not that eta, eta is also intrinsic impedance. So, the eta is equal to R radiation divided by R radiation plus RL, which is equal to, what is R radiation, guys? Which is it is 0.6 value. So, you need to find out R radiation here. How do you find out the R radiation? There is a formula. For Hertz dipole, it is 80 pi square dl by lambda whole square. So, the length is 3 centimeters. What is the wavelength here? It is 3 into 10 to the power of 8 divided by frequency is 1 giga. So, 1 into 10 to the power of 9. So, which is 0.3 meters. So, it is R radiation is, it is 80 pi square dl by lambda whole square. It is 3 into 10 to the power of minus 2 divided by 0.3 whole square. So, check out this value. This is 7.9 ohms, approximately 8 ohms. So, you have got R radiation, you can substitute there. So, it is 7.9 divided by 7.9 plus RL, which is equal to 0.6. So check out for this value. R radiation, R loss will be equal to 5.26 ohms. So what is the answer, guys? 5.26. Option D is the answer.
Related to the electronic measurements and instrumentation subject questions, solutions I am going to discuss. This subject name is generally called as measurements. This is also called as measurement, nothing but it covers electrical measurements, electronic measurements as well as transducer part, but the subject title is this, right? Now let us start the questions here. Here is the first question. A simple slide wire is used, nothing but this is a question from slide wire DC potentiometer, and this is used for measurement of current. So he is measuring current, and the data is given like voltage drop across a standard resistor of 0.22 ohm is balanced at 75 centimeter, nothing but 0.22 ohm. Resistance is 0.22 ohm. This is balanced at 75 centimeter. Nothing but 75 centimeter length related resistance is 0.2 he has given. After that, the magnitude of current is a dash. He is asking current. If the standard cell EMF, what is that? V standard cell is equal to 1.5 volt. This they want to balance it 50 centimeter. They want to balance it 50 centimeter. Under this condition, what is the current through the circuit? Now simple, 75 centimeter length is given. We need to find out 50 centimeter length correspondingly resistance. So simply 75 centimeter length resistance is given 0.2 ohm. In the same way, 50 centimeter how much? Why sir? 75 centimeter is balanced related to 0.2 ohm. So then our balancing should be at 50. Therefore, what is the resistance? Therefore, R is equal to 50 centimeter by 75 centimeter into 0.22 ohm. Right. If you simplify this, 25 to 25 3. So simply 0.4 ohm by 3. 0.4 by 3 ohm. Okay, this is the resistance. Okay, now simply I is equal to V by R. Sir, this is the length balanced with which voltage? 1.5. Therefore, 1.5 is the voltage by resistance 0.4 by 3 I am writing over here. Now what will be there? 4.5 by 0.4. Don't waste the time in this calculation. Simply 4 11s of 44 means approximately 11. So check it here. Only one option is there, directly 11.25. So answer you will be getting 11.25 amperes. Right? Next question. Which one of the following meter has minimum loading effect? Right? Under circuit, under measurement. The question is minimum loading effect. Indirectly what we can say, the device which should have high sensitivity. Check it here. 10 ohm for 1 volt means 1 volt has a 10 ohm, 1 volt has a 20 ohm, 1 volt has 100 ohm, 1 volt has 1000 ohm. So which is having more resistance? 1000 ohm for 1 volt only, but here 120 10. So automatically this is having high sensitivity, which implies here minimum loading effect. Right? Next question. The ballistic galvanometer, right? Damping follows. In the ballistic galvanometer, damping is of which type? So direct question, logarithmic function will be there. In the logarithmic notation, the corresponding damping will be following. So therefore, in the ballistic galvanometer, which type of damping follows which type of nature means logarithmic nature. Right? Next one. Which of the following types of instruments could be used to measure peak value? Guys, PMMC measures which value? Average value. CRO, V peak to peak, V peak, VRMS, time period, frequency, everything. And here V peak is there, okay. But peak value, maximum value is possible. And spear gap voltmeter also, yes, can read peak value. Therefore, what is the answer? Both B and C. Both are correct. Right? Next question. A resistance strain gauge. This is the question from transducers, that is resistive transducer. In that resistive transducer, strain gauge topic. Okay. With a gauge factor 4. So what is the gauge factor they have given? Gauge factor is given as 4. And then fastened to a steel member subject to a stress of. So stress is given. Stress means simply sigma we can say. What is that? 100 Newton per mm square. The modulus of elasticity. Modulus of elasticity are Young's modulus. So simply denoted with YRE. What is the value? 2 into 10 power 5 Newton per mm square. Newton per mm square. The percentage change in the resistance is dash. They are asking percentage change in the resistance. Percentage delta R by R is a dash. Now very simple. So gauge factor is given. For this question, we should be able to recollect the formula of gauge factor. What is the gauge factor formula? Gauge factor is equal to delta R by R by strain. Delta R by R by strain. Guys, what is the strain formula? What is the strain formula? Strain epsilon is equal to stress by Young's modulus. Why, sir? The Young's modulus is equal to, Young's modulus formula is stress by strain. This is a general formula we know. Stress by strain. Now, what we require? Strain we require. Therefore, stress by Young's modulus. That will be written stress by Young's modulus. What is stress? Stress is given as 100 by Young's modulus 2 into 10 power 5. Guys, both are having same unit, no need to mention, and the 2, the strain is of no unit. Delta L by L, change in length by original length is the formula of strain. So definitely no unit. And here, what will be there? 50 into 10 power minus 5. This is a strain. Don't write any unit because it is a unitless component. Now, therefore, gauge factor is equal to delta R by R by strain. What we require finally? Delta R by R. So from this, what we can write now? Delta R by R is equal to gauge factor into strain. What is gauge factor value? 4 into. What is the strain value? 50 into 10 power minus 5. So therefore, 200 into 10 power minus 5. This is also no unit. Why? Delta R by R, ohm by ohm, no unit. But don't wait and don't get confused with the options. Here, he is asking clearly, which one? Percentage change. But we got only delta R by R value form. Therefore, percentage delta R by R is equal to, percentage delta R by R is equal to, what is that? 200 into 10 power minus 5. Percentage is there? No. We need to multiply with 100. Now what will be there? 2 zeros and 2 zeros, 4 zeros, and here 5 zeros are there. Therefore, 4 and 4 will be cancelled. 10 power minus 1 into 2 means directly 0.22%. 0.22%. So this is the answer. So these are the questions from the measurement subject. Clear?
Engineering Mathematics. I'm Mathematics faculty, ACE Engineering Academy. The solution of the differential equation at dy by dx equal to x square y with the condition y equal to 1 at x equal to 0. Means if you take x equal to 0, y should be 1. Please observe, if you take x equal to 0, you will get y value 1. You will not get y value 1 because 1 by 0 infinity, e power infinity, infinity, so it is eliminated. If you take x 0, ln y equal to 4. So y equal to e power 4. But the condition is at x 0, y 1. These two not satisfying. If you take x equal to 0, ln y equal to 0, y equal to e power 0, 1. It is satisfying. If you take x equal to 0, e power 0, 0 cube 0, 0 by 3, y equal to 1, e power 0, 1. So only option C and option D satisfying the given condition. Therefore, we are unable to identify the exact answer, so we have to solve as per the procedure. But before that, here x square, if you integrate x square, it will become x cube by 3. So x cube by 3, that is there in option B. There are more chances for option B to be true. So therefore, the given differential equation is a dy by dx equal to x square y. Variable separable method means all y terms one side, x terms other side. Then it becomes dy by y equal to x square into dx. So integrate both sides. Integrating both sides. Integral 1 by y dy is ln y. So integration of x square dx is x cube by 3 plus c. Now what is the condition we were given? X is 0, y 1. At x equal to 0, y equal to 1. So take x equal to 0, y equal to 1, then it becomes ln 1 equal to c. X is 0, y 1, ln 1 is 0, 0 equal to 0 plus c. Therefore, ln 1 is 0. So c value 0, substitute c value 0 in equation 1. So equation 1 implies that ln y equal to x cube by 3 plus c already 0. Therefore, from this y equal to e to the power of. So, from this y equal to e to the power of x cube divided by 3. Answer y equal to e power x cube by 3. Therefore, as we already guessed, option D correct. So, option C wrong. Next problem. If the characteristic equation of the differential equation has two equal roots, then the possible values of alpha are. So when you write the auxiliary equation for this, you will get d square by dx square, that is capital D square, plus 2 alpha into d by dx, that is capital D, plus y coefficient is 1. So roots has two equal roots, then the values of alpha are. So therefore from this, if it has two equal roots, what are the roots of the auxiliary equation? Then d equal to minus 2 plus or minus square root of b square. If two roots are, instead of doing this, why can't we directly, it's a discriminant b square minus 4ac is 0. I mean ax square plus bx plus c. B means 2 alpha. 2 alpha square, 4 alpha square minus 4 into a1 c1. So divide both sides by 4. So alpha square minus 1 equal to 0. B square minus 4ac. So alpha square minus 1 equal to 0. Therefore alpha equal to 1 comma minus 1. Do you know if two roots are real and repeated, then b square minus 4ac value 0. So b square, that is 2 alpha whole square, that is 4 alpha square minus 4ac. So alpha equal to plus or minus 1. Therefore alpha equal to plus or minus 1. Therefore option A is the right answer. The characteristic equation of a 3 by 3 matrix is defined as alpha equal to this. If I denotes identity matrix, then the inverse of the matrix P will be. So first of all, we were given the characteristic equation, that is lambda cube plus 2 lambda plus lambda square plus 1 equal to 0. So by Cayley-Hamilton theorem, every square matrix satisfies its own characteristic equation. That means replace lambda by P. Then it is P cube plus 2P plus P square plus I equal to 0. Multiply both sides by P inverse. Then it is P inverse into P cube plus 2P plus P square plus I equal to 0. Right side P inverse into P 0. P inverse into P cube, that is P square. P inverse into P, that is I. P inverse into P square P. P inverse into I. P inverse equal to 0. From this, what is P inverse value? We were asked to find P inverse. So from this, P inverse equal to minus of P square plus P plus 2I. Minus of P square plus P plus 2I, minus of P square plus P plus 2I. Therefore, option D is the right answer. Next, if xy is a continuous function defined over the interval 0, 1 to 0, 1, given two constraints x greater than y square, y greater than x square, then the volume of f of xy is. So first of all, let me draw x equal to y square and y equal to x square. Draw the diagram of x equal to y square and y equal to x square. So this is y equal to x square parabola. Next x equal to y square. This is y equal to x square. Y square equal to x parabola would be like this. This is y square equal to x, I mean x equal to y square. Sketch the area occupying between two parabolas. Sketch the area occupying between two parabolas. Now this is 0, 0. Here this is 1, 1. By solving these two equations, you will get xy coordinates of this point, which is 1, 1. So therefore volume formula, x greater than y square and y greater than x square. X greater than, this is x equal to y square, x greater than y square means this, y less than x square means this. This is only the area we have to sketch. So do you know volume formula? Volume formula double integral f of xy dx dy. This is volume formula. So to find the limits of any double integration problem, let us choose a vertical strip or horizontal strip. If you choose a vertical strip, whether the resulting answer matching the answer or not, we will verify. So vertical strip, here lower curve is y equal to x square. So lower curve y equal to x square. Do we have this y equal to x square? Y lower limit x square, y upper limit root x. Y lower limit x square, y upper limit root x, we don't have in any option. Therefore choosing of vertical strip is not suggestible. So therefore let us choose a horizontal strip and then we will verify horizontal strip. So let us choose the horizontal strip. This is the horizontal strip. Now we will verify horizontal strip left edge is this. If you take a horizontal strip, you have to write x limits first. Left edge is this, that is x equal to y square. Horizontal strip right edge is this, that is x square equal to y. From that x equal to root y. Now to cover the whole area, this horizontal strip moves from 0, 0 to 1, 1. So the total area will be covered. So therefore here y limit 0, here y limit 1. So y limits 0 to 1, f of xy dx dy. This is the volume we were given. Y limits 0 to 1, x limits y square to root y, f of xy dx dy. Therefore option A is correct. Please verify. No other option will have these values. Which of the following is true for all possible non-zero choices of m and n, where m not equal to n, are all possible non-zero choices of real numbers p and q, where p and q not equal as applicable? Now you observe, this is odd function, this is even function. Product of even and odd function is odd function. If it is odd function, integral minus a to a f of x dx, therefore it is 0. Therefore option D is the right answer. Laplace transform of a plus bt whole square. So a plus bt whole square equal to, that is a square plus 2abt plus b square t square. So taking Laplace transforms both sides, then it is Laplace transform of a plus bt whole square equal to Laplace transform of a square plus 2abt plus b square t square. So do you know L of k is k by s, k value a square. L of k by s means a square by s plus 2ab into Laplace transform of t 1 by s square plus b square into Laplace transform of t square is 2 by s cube. So 2b square by s cube. 2b square by s cube. Please check the options. A square by s, 2ab by s square plus 2b square by s cube. It is there in option C. Please verify. A square by s plus 2ab by s square plus 2b square by s cube. It is there in option C. Therefore option C is the right answer then. So read the question. From a regular pack of playing cards, 2 cards are drawn at random. What is the probability that both will be kings if the first card is not, if the card is not replaced? If the card is not replaced means it meant for, once again, from a pack of 52 cards, 2 cards are drawn at random. What is the probability that both will be kings if the card is not replaced? That meant for 2 cards are drawn one after other. So therefore, probability of first card is king, that is 4 by 52. Card is first card not replaced. So we have total 51. Out of 51, we have only 3 kings because first is king which is not replaced. So therefore, it is 3 by 51. So therefore, 4 ones, 4 13s. So therefore, the answer P equal to 3 by 51, that is 3 by 51, 3 ones, 3 5s are 15, 1 1, 1 5, 3 6, 6 6 3, 6 6 3, therefore that is equal to 1 by 3 2s, 3 2s, 3 1. So therefore 13 1 3, 13 into 51 is 663. So if it is 663, then 3 by 663, 3 2s, 3 2s, 3 1s, 1 by 221. 1 by 221, that is there in option D. Therefore, option D is the right answer. Next, what we were asked? We were asked to find the coefficient of x minus 2 whole square in the Taylor series expansion of f of x equal to x into e power x about the point x equal to 2. So we were asked to write the Taylor series expansion of x into e power x about x equal to 2. If you want the series expansion about x equal to 2, x minus 2 whole square. So what is x minus 2 whole square coefficient in the Taylor series expansion? X minus 2 whole square coefficient in the Taylor series expansion about x equal to 2 is f double dash of 2 by 2 factorial, f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial into f double dash of a. X minus a whole square coefficient f double dash of a by 2 factorial, x minus 2 whole square coefficient f double dash of 2 by 2 factorial. So that's why let us find f double dash of x. UV rule, u into e power x derivative e power x plus e power x into x derivative 1. So plus x plus 1 into e power x. So find f double dash x, again UV rule, u into v derivative, x plus 1 into e power x derivative e power x plus e power x into x plus 1 derivative 1 only. So f double dash x equal to, if I take x plus 2 common, e power x common, x plus 1 plus 1, then it is x plus 2 into e power x. Then, f double dash of x only, this is. So take x equal to 2, f double dash of 2 is 2 plus 2, 4, 4e square. 4e square, but x plus 2 whole square coefficient, x minus 2 whole square coefficient, x minus 2 whole square coefficient equal to f double dash of 2 by 2 factorial. F double dash of 2 is 4e square by 2 factorial means 2, therefore it is 2a square. So do we have 2a square in the options? Yes, 2a square it is there in option B, therefore option B is the right answer. Now you observe what is the value of the integral, x tends to 5. What is the value of the limit? Let me write the limit first. Limit x tends to 5, x square minus 4x minus 5 divided by x square plus 2x minus 35. If I take x equal to 5, 5 square 25 minus 4 into 5, 20, 20, 25 minus 25, 5 minus 5, 0. Again 5 square 25, 5 square 25, 2 into 5, 10, 25 plus 10, 35 minus 35, 0. 0 by 0 form, apply L'Hospital rule, means differentiate numerator and denominator with respect to x. X square derivative 2x, 4x derivative 4, x square derivative 2x plus 2x derivative 2. So take x equal to 5. 2 5s are 10, 10 minus 4, 6. 2 5s are 10, 10 plus 2, 12, 6 by 12, that is 1 by 2, 0.5. Okay, we have 1 by 2 in the options, therefore 1 by 2 is the right answer. 1 by 2 is there, 6 by 12 means 1 by 2, that is there in option B. Therefore, option B is the right answer. So, these are the questions. Thank you.